Select. PDF है controller की
Okay, I did. Okay. Okay. So I will introduce. Good morning to everybody. So today's lecture keynote speech is by Prof. AD. He is a Deputy Vice Chancellor Development of University Technology Malaysia. University Technology Malaysia is 38 QS Asia ranking and 188 of world ranking with 46 Miss Stanford University top 2% scientists. There are 20,000 students and about 200 postdoc. And so there is a lot of opportunity, and about 80 countries, student researchers study there. So are you able to see Prof. Edi?
Yes.
PPT.
Yes.
Okay.
Dr.
Then
Ramesh.
you can proceed and you can say next, then it will be done next. Okay.
Yes, thank you very much, Dr. Ramesh, and very good morning.
Director Professor T.N. Singh is also sitting in the front row.
I see. Right,
Okay.
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 Very good. Good morning. First of all, I would like to express my sincere appreciation to IIT Patna for kindly inviting me, especially to Prof. Tian Singh and all the committee members and the conference participants today. I also would like to express my apologies for not being able to come to Patna due to the accreditation audit that currently held in the university. So I hope through this video conference we could establish the connection, and probably next time would kindly invited IIT Patna to UTM for the future projects or programs. So today I would like to share my insight into the something that is important, understanding the basic of the ground. Some that will relate to many engineering applications. For example, like the energy infrastructure and disasters. So while dealing the issues with the ground, of course, the understanding into the basic of ground is very important. So here I would like to share in terms of the weathering profile of the tropical ground. Okay, next please. Next please. Next slide. Yeah, thank you very much. Okay, and as it is generally understood that the typical subsurface profile consists of this top soil and then transported soil, where the topsoil is much different compared to the transported soil, where the transported soil depend on the history and the environment of the decomposition. That means it's been carried away from other sites to the in situ place. And then the residual soil, the third layer, is where the soil that generated from the decomposition of the rocks then it has been disintegrated and decomposed to the secondary or the tertiary minerals, and then the this is the originated from the parent rock, while the bottom part is the bedrock. Much depend on the structures, formation of history, and the rock type. So it is much dependent on the bedrock, the type of bedrock that will generally influence the parameters and the behavior of the underground. Okay, next slide, please. So when we talk about this bedrock and the soil, we have some important zones where these zones always become confusion. That means the intersection between the soil and the bedrock. This is where many of the um, scientists or maybe the practitioners has the um, confusion and something that is not straightforward. It is not like mathematics, but sometimes we have to use the ability of our feelings, the arts, in addition with the scientific knowledge that we have. So because this is the mixture of the soil and the rocks that always become confusion zones. This is the geological map, just to introduce you on the ground in Malaysia. On the right-hand side, where you see the red color, that is the eastern belt of granites. That is one layer from the north to the south. And then at the central part, you will see the green color. And then on the left-hand side, you can see the orange color. The orange color is the western belt of granite, meaning that the eastern part of granite, that is red in color, and the western granite, which is orange in color, there's two um, uh, mountain range from the north to the south, and it is also situated on the western part from the north to the south as well. But at this middle of this mountain range, you can see the greenish color, which is the sedimentary and the metamorphic that generated from the sediments area. So we have the two mountains on the right and the left, and then at the middle part, it is situated the sedimentary and metamorphic rocks. So we have the very different type of rocks generated from the past histories 200 million years ago, and the latest one about 100 million years ago when Malaysia is more stable. So this is the one of the important thing when we are dealing with the underground application in Malaysia. This is just to show and share how the ground and the rock type plays very significant different when we try to deal with any part of the disasters or any geotechnical or geomechanical application in Malaysia. So we do have a lot of issues here in Malaysia, where in Kuala Lumpur, for example, situated at the central part and then western side of the Peninsula Malaysia here, where we have the limestones, granites, and the Kenny Hill Formation, that is sedimentary. So we do have three types of very big difference of the rock types in Kuala Lumpur itself. And then we do have a lot of issues For example, like the Kuala Lumpur City Centre, the KLCC tower, the Petronas Tower, if you may know, that is situated on the limestone area. And then we do have a lot of the issues, especially when the construction time, where the location have been shifted 2 times before it is before it is really built on the exact ground as what you can see today, due to big cavity that it is found underground. Okay, next slide, please. This one is just to share with you on the difference between the typical profile of the sedimentary igneous and the limestone profile, where in limestone we may have different problems, for example, like the cavity, pinnacles, karstic formation in the limestone area, while in the igneous you could we could expect a lot of boulders exist. And then in the sedimentary, we could see the heterogeneity of the ground depending on the different rock type that interbedded in the sedimentary formation. Okay, next slide, please. Here is the photograph showing the different type of ground. And then on the left-hand side, you could see granite with where the profile is very much different as compared to basalt. Basalt at the middle part, that is brownish um, soil, and then you can see the ground, the rock is a little bit darker. And then on the right-hand side, it is limestones. So it affects the topography and geomorphology of those areas. And then at the lower part, you can see the sediments, the heterogeneity of the ground, where the hard layer and the soft layer is interbedded. It is much dependent on the type of rock, which later on it will influence the behavior, the strength of the each layer and each side. Okay, next slide, please. Next slide. Okay, this is a photograph to show the ground dominated by shaly area on the left hand side, and on the right hand side is on the sandy type of bedrock. So it is very much different, and then we have a lot very big varieties in terms of the issues, and something that we could actually predict in the future what kind of the general concern and the disaster could actually dominate that area. Okay, next slide, please. This is in the limestone area where we obviously could see the stalactites, stalagmites, and the cavities inside due to the dissolution process happens very easily due to the calcite minerals, which is weak and easily dissolved in the rainwater. Okay. Okay, next slide, please. This slide shows the transported soil. On the left-hand side, you could see the white sand actually being transported elsewhere, and then now it is becoming the sand mining area where the top soil being excavated and removed before we get the white layer sandy layer at the bottom. On the right hand side, you can see the lorries. There is actually in the same area where the sand had already been processed. Okay, next slide, please. This is the typical texture and the look of the residual soil of granite. It is sandy and reddish brown in color. Okay, next slide. It is due to the minerals inside. There is quartz, feldspar, hornblende that will affect the texture and the secondary minerals in it. While this one is the residual soil of basalt, you can see it is different color, different texture of ground, and this is brownish color and less sandy size minerals. Okay, next slide. Okay, and then this is the similar chemistry as granite, but this rhyolite come from the volcanic origin, and then we could see almost the similar color with granite, reddish brown, but lesser sandy type of minerals in it. Okay. So meaning here, I would like to show that the bedrock actually really influence the look, the color, the texture of the residual soil generated from it. Okay, next slide, please. Now, we already understand there are non-similarities between the different ground, different rocks, and then we have different issues. For example, like in the limestone, we could expect the cavity inside and the karstic formation underground. In the sedimentary, we may anticipate the difference of layers, behavior, and then the structures also affected. And then there are also boulders that could abundantly could be observed in the granitic residual soil. But the challenge is how to make sense of what we are actually investigated. For example, in this slides, you can see on the left-hand side, that is the image of seismic velocity, showing the different color, showing the different velocity of wave in the ground. And the right-hand side is the borehole records where we bore a certain number of boreholes in the ground, and then we have the spotted, the localized information at that particular location. But the thing is how to make sense of the underground challenge before we could really understand the condition of the ground, and later on we could use this information to design, to foresee, and to anticipate the kind of challenge and disaster that we could take steps to minimize all the potential risks. Okay, next slide, please. Okay, this is the different background of the granitic area which we have investigated. For example, like the right-hand side, where we actually do the very detailed mapping, and then we try to understand the difference between the upper part of the profile to the bottom part of the rock mass. So at each particular section, we do all the joint spacing and then joint mapping, and then we also understand the material strength and the all sort of the engineering parameter for each material situated at different part of the profile. So basically here at the lower part, that is the diagram and sketches are showing the difference between the zones, which could be easier for us to understand, where the darker color of the um, soil is the top soil, and then the yellow color, that is the residual soil, and then the residual soil has different, very much different parameter compared to the top soil, and then we do have the different in terms of the different zones generated. And then the next slide will show what's the difference of the parameter. Next slide, please. Okay, this is also showing the Menang quarry, the one side. We do the detail mapping where you can see Dr. Ramesh over there doing the investigation at the quarry, do the detail mapping in the quarry. Okay, then next slide, please. Okay, here is the changes in terms of the different weathering state of the granites, where on the right hand side you can see the top part, that is the grade 2, that is slightly weathered minerals. It is still well preserved minerals, where the bottom part, that is grade 3, that is the moderately state, where we can see there are some mineral changes, especially the mica and the feldspar already being decomposed, and then the lower part, that is grade highly weathered, and then the bottom part where you can see the mica and the feldspar are almost being decomposed, that could be observed in the highly weathered granite area. And then these are the changes of the minerals inside the original granite, the fresh granite that change from one state of weathering to another state of weathering. So we could observe here the first type of minerals that being weathered is the mica minerals, and then followed by feldspar, and then that feldspar could be the index minerals that can be observed and understood the state of weathering that it has undergone. Okay, next slide, please. Next slide, please. Okay, and then from here we do create model on the typical profile in granites. Here on the top part, you could see you can have complete from zone 6, that is the residual soil, then followed by the completely weathered, then highly weathered, moderately weathered to slightly weathered. That is complete. But we also could anticipate type 2, where there's only a few zones that in this case we only have completely weathered, highly weathered, and fresh. So the moderately weathered is not exhibit over here. And then on the bottom left, there is type 3, where we have the completely weathered, highly weathered, moderately weathered, and slightly weathered, where the highly weathered one, it is not observed in this site. So meaning that here we want to show there are, even in granites, we could anticipate different type of weathering profile that is not so typical, and we have to prepare that if this kind of situation happen, then what kind of steps could we, or measures that could we take to avoid any potential risks in this in this area. Okay, next slide, please. Okay, and this is the physical properties. Here we learn about the water absorption and porosity of different weathering state of granite. And then, for example, on the completely weathered giant, in terms of the water absorption, shows it is between or 6%, where you find about 10%, and I think about 1%. So here, it is meaning that it is the site-specific condition. It is not always could be used for all type of sites, but it is important to see here that the porosity and the water absorption much dependent on the different state of weathering. It is also including the density, where we could see on the highly weathered to the completely weathered, the changes is a bit drastic. Okay, another slide, please. Okay, and then this is the difference in the limestone. Just now it is in granite. Now it is in limestone. In that sense, it is also the changes is very significant, and then it is obvious, saying that the top part, water absorption, for example, at the fractured limestone is between 0.9 to 1.5, whereby the water absorption for the moderately weathered is reduced from 0.6 to 1%. So here the changes is also quite drastic, and we could anticipate the different problems at the different zones. For example, if we would like to construct or design a slope, then this parameter could be useful for us to as the input parameter, or something that we could actually look into. Thank you. Then another slide, please. Okay, so in general, as what we could see just now, the changes between the different type of bedrock and different weather state carries different parameter and different behavior of the particular zones. So the understanding of the subsurface profile from various background is very, very important and crucial, and is also helpful for us to understand the expected engineering properties, problems that probably could be dealt with, and then also we also could actually come up with the potential mitigation measures to reduce the potential risk at the different type of rocks. So here I would like to say thank you very much, express my sincere appreciation, especially to Prof. T.N. Singh, Dr. Ramesh, the committee members of Iit Patna, and all the participants. And I wish the conference be successful and wish that we could meet in the future. Thank you very much. Thank you very much.
Thank you, Professor Edie,
Thank
for a
you very
very
much.
nice presentation and refresh us about this, how this rock will behave, having the different degree of weathering.
Yes.
And also you reminded me my last visit to the limestone quarry, where
Yeah.
I have visited with Dr. Ramesh. Thank you very much. And
Thank you.
we-
Thank you very much,
we-
Prof. Prof. Tian Singh. Hope we
yeah,
can meet up some other time and wish you all the best in the
thank you.
conference.
Thank you. Thank you.
Bye.
Professor Eddy, this is Dr.
Yes.
Goyal.
Yeah, Dr. Gaya.
Good morning.
Morning.
I found your work very interesting
Thank you.
because we are also carrying out the similar study here, wherein what we have tried is to see how the RMR and Q value varies with the weathering grades.
Yeah.
So
Yes.
in that aspect, this is really very good. Very good
Yes,
work.
thank you very much, Doctor. And then of course, it much related and influence the Q value, the RMR, or any other type of rock mass classification in the different type of bedrock, different weathering state as well.
Yeah, I will share that paper with you.
Thank you very much.
Okay.
Please.
Thank you very much. Thank you very much.
Thank you very much. I may leave now.
Yes, thank you very much once again.
Thank
can
you. Thank you
continue
very
with
much,
your
Prof. Tian Singh.
other assignment.
Yes, yes. Thank you. Bye.
Second day, keynote speaker. बोला तो पहले सब भैया ने बोला ले चला देना जब बोलना होगा तो विशाल सही चल पोजीशन में उसको हटा अरे एक मिनट रुकिए यूट्यूब पे जा रहा है वो दीजिए रिमोट लाइव जा रहा है तो सेटिंग करना पड़ेगा सीधे अरे वो कैमरा वाला सर यूट्यूब का सेटअप कर देते हैं और फिर चल जाएगा उसका आप सेशन स्टार्ट करो ब्लॉग यूट्यूब पे जा रहा है तो यूट्यूब पे जा रहा है तो सब सही कर रहा है यूट्यूब वालों को सीधे पढ़ रहा है इसी से पढ़ रहा है ठीक है और इनको चलो आपकी यूट्यूब स्पीकिंग फ्रेम करके नहीं रहा है सर पे पढ़ चलो
Hello everyone. So in the continuation of this chain, we would like to invite our next keynote speaker, that is Professor Ramesh Vandanapu sir. who is Assistant Professor, MIT University, Dubai, UAE. Dr. Ramesh is a highly qualified program leader and assistant professor in civil engineering. He earned his PhD from Kingston University, London, UK, for his research on collapsible soils in the UAE, which earned him an honorable mention award at 2018 ABTA, Association of British Turkish Academics, Doctor Research Awards. He has over 16 years of global experience in civil engineering, including construction, consulting, teaching, educational assessment, classroom management, and student relations. His teaching philosophy emphasizes practicality in the field of civil engineering, and he believes in a realistic approach to understanding engineering concepts. Before transitioning to academics in 2011, Dr. Ramesh worked on various geotechnical investigation projects in India, Oman, and UAE for more than 6 years. His research interests focus on forensic geotechnical engineering and understanding the impact of human activities on geotechnical changes that cause damage to civil engineering structures. So please welcome Professor Ramesh Vandanapu, sir.
Presentation. Presentation.
Yeah. Is my voice audible? Yeah. Good morning, everyone. And thanks a lot for giving this opportunity to have my keynote speech in this prestigious conference. So basically, I'll be talking today on geotechnical engineering only case studies, and where the site history was not taken into consideration while designing the projects, because of which there are many issues that has been faced by the infrastructure in UAE. So those case studies I'll be taking here today and I will be talking about. So basically, what happens here in many countries is whenever we are constructing any infrastructure project, the consultants or the contractors will not have site history data, like what happened at that particular construction site in the last 25 years or 30 years or 40 years. We unknowingly, one day we will start the project, consultant will design, contractor will construct. Later on, after 5 years or 6 years or 10 years down the line, we'll be facing some issues and we'll go back, what happened, where is the problem, and we identified that there is some case, some site history which was there in the past which was not considered. That was these kind of cases we have found out in our many forensic investigations that we have conducted. Those things where we ourselves have involved while we are designing the projects, what mistakes that we have that has been made, also will be talking here. And yes, when we talk about the case study one, you can see here there are many places in one of the project in UAE where the ground has been subsided, the roads has been damaged very badly, and also you can see in the picture here, the building was perfect, but the boundary walls were damaged. So these are some of the issues that has been raised in one of the infrastructure project. You can see here all the cracks on the roads, buildings have been cracked, buildings are being here okay here, but the entire footpath has been subsided. All these problems have been faced in one of the project in UAE. You can see here the boundary walls has been toppled here, the footpath has been damaged here, and when you see the soil has been subsided, but the boundary wall was perfect. Okay, so when this project has been constructed, um, there were no problems. Down the line, after 5 years, 6 years, 7 years passed, one day they faced small problems, and after a few months, there were many issues that has been raised, and it has been brought to us to conduct a forensic investigation. What was the reason behind it? So then what happened? We went to the site and we drilled some boreholes. We did some cone penetration tests on the soil. And finally, what we understood here is investigations are majorly happening in many cases, and lot of money is being involved in the investigations after some problem happened. And in many investigation projects, when the new project is being constructed, people are not allocating good amount of money in terms of investigating the site thoroughly. They will, yesterday also one of the speaker has told, we will allocate only less than 1% of the project total cost for properly investigating the ground data. So later on when some problem comes, no, we drill boreholes everywhere. This is a problem that is being faced in the practice. So that is the reason we need to allocate good amount of money in terms of investigating the ground and understanding the ground data before the construction activity starts. So when we see in the previous photographs, when we went to that area, not all the villas, not all the roads were damaged. Only in a particular section were damaged. So our main idea is when we drill the boreholes in all the place, we need to identify what is the reason behind such happenings. So surprising thing is not all the villas are distressed, only in a particular zone are distressed. What is the speciality of this particular only in that specific zone? So when we find, we were confused and why only few villas were damaged. So then what we investigated is we went to the site, and then when we asked the people who are around, we asked what are the construction activities that are happening around. We came to know that before these damages were happened at that particular site, there has a contractor that has came and a big road was there already. Beside that road, they were constructing a pipeline for which they have made an excavation, and the contractor has did dewatering for that. They did dewatering. So basically, whenever a contractor has been given a dewatering job to lower the water table, if at all you want to lower the water table to 2 meters or 2.5 meters, they'll keep the water table 3 meters below or 3.5 meters below, so that we will have a dry environment when the person is standing inside and working. But actually, if the contractor do more work and they spend a lot of money in terms of making the project safe, if they dewater more than what is required, that also a disaster. That means the contractor is spending money and giving a lot of bill to us, and we are paying it, and finally we are ending up in a disaster. That is what it is. So that is the reason. What is the reason for this particular project is we are having a dewatering at that particular site. For example, those people who know swimming, when you are swimming in the water, you feel it light. When you come out, you will feel heavy. So that is the reason whenever we are lowering the water table in the ground, we are making the material which is feeling light when it's in the water, we are making it heavy. Understand? Because of that, the weight of the soil is increased and it is collapsing the soil which is below it. That is one of the problems that we have faced. And yes. So what we understood from here after conducting the investigations was, you see this patch which was marked, though there are many buildings which are there here, only the buildings, only the roads which are there in this particular patch were damaged. No damages here, no damages here, no damages here, no damages here. Only damages are in this particular part. So what we did is we went to the local municipal authorities and we have asked, give me the old 30 years, 40 years back, before the site has been developed, how the site looks like. So they given the maps to us, and we have superimposed those maps on the existing maps. And then what we have seen there is, when this area has been allocated by the municipality for the development, there was a canal there. There was a canal there, and when they filled this canal with soil, and the municipality is giving this particular work to infrastructure development, it was done in very fast manner, and they did not fill the soil, and they did not put the controlled filling into that particular canal. And then it was loosely left in that particular canal, and the entire area has been given to many people for construction of the villas. And then this dewatering guy came, and then they did the dewatering, and all the soil which is there in this particular canal portion, which was not properly compacted, has been subsided. So what we have understood from this case study is we need to know what is the history of the site prior to construction. That is what is the learning that we have seen. Yeah, as I told, we are constructing the pipeline here. The contractor has been asked to lower the water table up to here. He lowered the water table up to more than what is required, which is making a problem in that particular area. Yes, that is one case study. In the next case study, what happened is, here also there is a problem at that particular site. So this is another case study where every box is a particular villa. There are many villas which were constructed at particular site, and we have got an investigation project where this portion which is marked in red, there are problems in that particular area only. And all the villas which are there all around it, no issues. Only in this particular area only, there are problems. So again, forensic investigation started. So when we went and drilled the boreholes, before starting we have asked them, what all, when this whole area is developed, give me the data where different boreholes are drilled. The first surprising part that we have seen is the place where these damages are identified, no single borehole was drilled, because this particular area is a very small area out of this big area. Because boreholes are allocated very far away from each other, no single borehole was drilled in this area. So now our area of concentration is only this area. So we drilled multiple boreholes in this area because our job is to identify what is the problem there, right? So when we drill the boreholes and we identified, again we have a very good surprise over there. What is that surprise is, again, the site history was not considered. Once upon a time, like few decades before, when there is no development here, there were some buildings which were demolished somewhere, and these building waste was dumped at this particular site. The building waste was dumped at this particular site, and soil is filled. Area looks very beautiful before the project starts. Understand? So project starts. So what happened is, when this entire area was developed, again, the construction waste was not compacted properly, and what happened? It is very loose. Again, the same problem. Beside this, there is a contractor which was constructing a pipeline, as did the dewatering, and this loose material, what is there inside it, has got subsided. So here also, one of the issue is, no site history was available for the people who are doing this project. You can see here, this is the construction rubble that we identified in the boreholes. This is the construction rubble that we have identified in the boreholes that we drilled in this particular area. Again, here also, I am emphasizing once again, whenever we are allocating a infrastructure project, we need to have good amount of funds to drill the boreholes very close by as much as possible to get as much as data. Otherwise, again, they have to burn their pockets in spending a lot of money to identify the reason, for what reason it has happened, right? Yes. So these are the lessons that has been learned. Yes. So now we'll move on to the case study 3. This is a very huge area where a high net worth individual person has constructed a villa in a very big area. And then to make his house very beautiful, the land was flat, and he has raised the entire ground up to 3-4 meters or 5 meters, and he has constructed a retaining wall all around, and this is all inside the retaining wall. He filled the soil, elevated the site, and he has constructed his beautiful villa on top of it. And then all around the villa there are full greenery areas. So he was living for 4 years, 5 years, 6 years. One day, problem started. So all around the green areas around his villa has been creating problems. Then again, they have called for the forensic investigation, and we went there and we drilled the boreholes. You can see one particular villa is there. Lot of greenery is there. There are peacocks, deers, everything is there around. You can imagine how much big it is. You can see the staircase is going down. Wherever there are plantations, there are gaps that are created in the pavements. You can see some of the soils that has been subsided and creating problems. You can see these balustrades are getting gaps. Some of the places where you have the flat slabs on the ground has been subsided. A scale has been kept to identify how much it came down. You can see the gaps that are identified here. So finally, what happened is when the investigation company has given this project to us, we went to the site and we drilled the boreholes. And what we understood from here is all the soils which were used for filling this particular area to raise the ground level up has been very loosely compacted. That is one thing. And also, the main thing is these soils are collapsible in nature. Collapsible means when the soils are very dry, there is no any problem. Only problem comes only when the water enters into it. The friction between the particles will be lost, and then the volume of the soil will get reduced. Obviously, if you are standing on a soil and the volume gets reduced, what will happen? It will go down. The same things happen to this. But there is no any problem that has been identified for the building, because these buildings are not resting on the soil, but they were resting on the piles, where these piles are standing on the bedrock. So there is no any problem for the building, but only the outside small infrastructure only having a problem. Yes. So here another case study is there. Here also there is a huge development. All the villas have been constructed. 6, 7, 8 years passed. People like you and me has purchased the villas and they were living. One day they got a notice saying that all this line of villas has to be vacated because there are problems that are being faced by the infrastructure. And you can see how the payment have been subsided. You can see how the footpaths have been damaged. You can see how the boundary walls has been damaged. You can see good amount of sag on the footpath beside this. You can see I can keep my writing pad inside. How much amount of cracks have been happened. You can see the toppling of the boundary wall moving aside. So here also what happened is, after everything happened, we got the investigation. We went there, we drilled the boreholes, and we identified that most of the problems, whatever I have shown in this particular project, everything is beside the green areas. Wherever we are dripping the water for growing the plants to make the area beautiful, we have a problem. And luckily, no villas have been damaged in this particular place, because most of the people in UAE construct even a small structures on the piles in many areas. That has been given direction by the municipality. So that is the reason there is no any problem for villas, because they are resting on the piles. Only the boundary walls, roads, these has been damaged here. So when we got a doubt that why these green areas are only giving problems, is this attribution of green areas to creating problems is really true or only our assumption? Then again what we will do, we will go and start drilling the boreholes. But here the villas are very close by and the roads are very close by. We cannot take the drilling machine to drill the boreholes. So we need to identify an alternate for that. So we did a lot of dynamic cone penetration tests, and we took a lot of samples from drilling very minor boreholes. And what we understood from here is the soils which are there in this particular area are also collapsible, and indiscriminately huge amount of water is being used for drip irrigation, and soils has been collapsed and the volume got reduced, and then there is no support for the small infrastructure that you have there. Understand? So they have asked us, is this soil collapsible in nature? They are asking us to check whether the soils having the susceptibility further to collapse, or this collapse has been finished. They have asked us. How we can say unless and until we do a real-time work? So that is the reason what we asked. We have taken a permission for one of the villa owner to vacate the villa, and this particular area has been flooded with water by us purposely. And then we installed a settlement plates, and then we identified after a few weeks whether the soils are responding for the entry of water or not. Understand? From that, we identified that whether the soils are further willing to collapse or they will say to us an indication that our collapse is finished. Understand? So this is one, and they have asked us, we cannot do such kind of operation because it is for a testing, we can do it, but in reality, how we have to overcome this. Then what we did was, we did a cement grouting in one of the boundary wall to verify whether we can able to have the gaps that are there in the collapsible soil filled with this particular cement grout. So we did that, and we have shown to them how to do it, and how the strength of the soil has been improved. After doing that, again we flooded this with water, and then we identified that the soil which was giving a response to the entry of water is not giving that much response. So that is one of the techniques that we have proposed and they have implemented in this particular project. Okay, right. So these are the 4 case studies that I would like to show today. And then what in reality what happens is, as we all know, most of the presentations from yesterday that we have seen are on rocks. Whatever the presentation that I have shown you as on soil, either the soil or rock, both of them are not manufactured by us like concrete. Understand? We are having always confusion about how closely that we understand this natural material. If it is a concrete, we'll make it as however we like. But if at all you are dealing with soil and rock, it is not a man-made material, so it is always giving a confusion to us. And also, whatever the lab test, whatever the field test that we will give, that we will do in the lab or in the field, they will only give an idea about only in the small scale, but in the large scale, again we need to use our common sense to predict how it behaves in a large scale, right? So that is the reason we always use as in the lab, we did some simulations. So large scale laboratory simulations we did. I'll try to show you. Yeah. So as I told you, in one of the projects where the damage is because of the water that is dripping into the ground, so we did a plate load test, which we will be doing at the site, but we did it in a large scale in the lab in 1 meter by 1 meter by 1 meter tank. And then whatever the dripping mechanism that is being used here, the same thing has been simulated here in the lab. And we have kept a water meter to it, and then we make sure that the quantum of water that is dripping from this is dripping into the soil, and we have seen how the soil responds to the movement of water, right? So basically in the plate load test, what we will be doing is, we'll be seeing how much pressure the soil takes as it goes, but in reality we have to do a constant stress method, which is when we are constructing the building, the building load is not going to change much. That means we are applying a stress which is constant in nature onto the ground mostly. But most of the tests that we do in the lab are strain controlled, but not on stress controlled. So our target is how to simulate here a stress control test in the lab and simulate the reality. So that is the reason what we did when we did the plate load test. We have calculated the stress that is required to be kept on the particular soil. As the water is dripping into it, as the soil is losing the strength, this stress will get reduced. But when it is getting less, we are giving the energy to it and then making it again constant. Understand? That is how we did the test. So this is the mechanism that we did for maintaining the stress constant. That is on a large scale. And if it is in a small scale, how to do it? We did, as everybody knows, CBR test, which is very simple one. But these molds were taken. What happened is we filled the soil into it, and these were kept in the water. If it is the height of the mold, and we fill the water up to certain height, that replicates the groundwater table in the soil, and then these infusions sets. Everybody knows when we join in the hospital, they will give a drip, right? Yes. So these drippers are used for dripping the water on this particular soil. Okay, but these drippers have been calculated in such a way that for a particular area, how the water is dripped for growing the plants, same has been simulated here. It is not just dripping the water on the soil. So that is how we did the real-time testing on the soil, simulating close to the reality. So what I would like to emphasize here is, whatever the testing procedures that are there available in the books or in the codes, sometimes you may not get full amount of idea how to simulate what actually happening in the site in the already available procedures. So sometimes we need to go forward and identify how you can simulate the actual things, what is happening at the site into the lab by giving your own idea. That is what it is. And we did one geotechnical modeling also in one of the projects here. As you see, these villas are nothing but these villas. We have taken 2 model villas and we did that. These are the soil layers and this is the boundary wall. So we did the modeling. I will not tell anything about modeling here. And these red lines indicates how the drip irrigation is done at the site and at what cycles. So we have inquired with those people, how many times they do the drip irrigation, at what interval they will do the drip irrigation, how much time they do in the morning, how much time they do in the evening. The same thing has been simulated in the software, all in the green areas. You have a villa, you have all the green areas. We simulated the entry of water into the ground and we identified that these are some of the settlements that we have monitored. Settlements found were around 100, 150, 120 mm, which is just nothing but a disaster for the boundary walls and all, right? So that is what we have identified in the study in terms of modeling. Yes. As I shown you, in one of the boundary wall, we have good amount of cracks here. So they have asked us how you can simulate in the modeling, how much it settles, how much ground support has been lost, all these things has been asked. So what we did in the modeling was, whenever a boundary wall is there and it is resting on the soil and we are watering that soil and soil is moving down, so that means the boundary wall is losing slowly its support. How much support is lost at which this particular failure has been happened, that we have tried to simulate in the software, and then we identified that approximately at 40% of the self weight it has lost, then the failure has been happened, and this failure, whatever you see in the software, is similar to what has been seen in the site, but you may not get exact perfect result every time. This is only a simulation software, and whenever you are using the simulation software, you need to be very careful, as since yesterday many people are using the software and they are showing many things. Whatever you give it to the software, software will give some output because it will analyze something and give out. But as a geotechnical engineer who has good amount of common sense in understanding the parameters that is giving out, it is our responsibility to understand whether the data which is giving at the end of the software analysis is correct or not. If you don't know how to analyze the data that it is giving, you think that it is right, but actually you are saying a right thing, but it is a disaster in the other sense. So you need to be very careful in understanding the output that the software gives. That is your responsibility. So concluding it, so basically, as I said, soil being a natural material, definitely it is not going to stop giving problems to us. It is our responsibility to keep facing it. And also I said, it is a natural material that you deal with rocks or I deal with soil. Definitely we cannot understand it fully forever. Problems are continuous and you need to deal with that. Okay. So as I said, good amount of budget has to be allocated in understanding soils or rocks well in advance. And as I said, there is nothing to say, everything, every geotechnical forensic investigation that we did so far in the last 10 years, there is no relation from one project to another project. Every time we are learning a new thing, every time we are finding, oh, this also could happen. This also happen. That is the reason always your strength on fundamentals in any engineering practice is very, very important. Then only you will be able to get an idea whenever you do a forensic investigation. Okay? So that's what I would like to conclude my presentation. I hope you got some good idea about what has happened in several construction sites in our forensic investigation. Thank you so much for giving this opportunity. Do you have any questions you may ask? Yes.
Had some preset ideas about subsidence and crack.
Okay.
But after going through your presentation, we have got some more insight about that.
Okay.
But I have actually two questions. One is like when you are doing borehole, what should be the interval and depth of the borehole? And another question is, suppose even if I have identified the reason why this subsidence is happening and crack is happening, then is there any solution? Like then after that, what we can do so that further, you have given one solution when the region is collapsible soil. And if the reason is like dewatering, then what we can do so that a structure should not get further
Yeah. So basically, whenever in a particular region, if any project has been identified that there are presence of collapsible soils present in it, so the local regulation should be modified in terms of whenever the project is being awarded to a consultant, it has to be make mandate that the collapsible nature of the soil has to be interpreted and written in the report whether the soil is having a collapsible nature or not. Understand, when we have a disease and when we go to the doctor will not do every test, no, only a particular test. Same like that, whenever the municipality is allocating the projects to a consultants, and if they already identified that there is a chance of collapsible soils in that particular area, it has to be made mandate that that particular nature is available for that particular soil in that area or not. That has to be done.
Regarding the borehole density.
Yeah. So basically, whenever we are spacing of boreholes is done, it is written in the local municipal guidelines that based on the floor area ratio in that particular area, for every 75 square meters, for every 100 square meters, one borehole has to be drilled. Like this, some regulations are there. Keeping these regulations in mind, the contractor will try to keep to budget as low as possible and keep the number of boreholes minimum. So that is the reason it is our responsibility to increase the number of boreholes as much as possible. But anyway, you cannot test each and every place in the ground. But as far as the depth of the borehole is concerned, obviously you will have a good idea before you start your work what could be the probable type of foundation that you do. For example, you are constructing a small room for a watchman, you will not construct a pile for it, right? So that is the reason some in UAE, in Dubai, Sharjah, Abu Dhabi place, where you are constructing a small room for a watchman outside a villa, they will make sure that a borehole is compulsory drilled at least up to 6 meters below the ground. Okay, and if at all you are constructing a multi-story project, obviously in geotechnical engineering we will study something called depth of influence, pressure bulb, all these things we will be studying. We'll make sure that at least 3 to 4 times the width of the foundation. We'll try to go further and try to identify how the soil is behaving till at least up to the bedrock.
Thank you, sir. Thank you so much.
So myself, Akash Kumar. Sir, I have a question that if you are filling a area with a dismantling material, so what a process should we follow, or what kind of material we should use to make it fully a compacted area so that these things doesn't happen?
Yes. So the very first important thing, the area which is being allocated for dumping the waste, the area which is being used, for example, if you take UAE into consideration, if your villa is being demolished, you cannot go and deposit wherever you like. You have to take the permission from the local municipality, and they will give you your permission. Yes, you can go and dump there. Being a person from the municipality, I am giving permission to you to go and drop your waste there. I need to have an idea in future from the government authority for what I am going to use that particular area in future. In future, I am going to use the dumping area for construction. Obviously, I need to take that in advance into the consideration. Otherwise, obviously, the same disaster that I have shown on the slides will happen in your project also. So the first thing that you need to remember here is whenever you are using the material from the construction sites, you need to demolish, and big chunks of material should not be dropped. And you need to divide into small chunks. And then whenever you are compacting it, after dumping at the site, you should not dump huge amount of material so that my job is done in a very fast manner. No. Whenever you are doing a dumping at the site, you need to do a controlled dumping. Controlled dumping means generally what municipality regulations in UAE says that you have to place a layer of 600 mm height, and then you need to do a compaction and make it at least 300 mm roughly. And then if at all you are using this particular site for construction future, make sure that you are going to reach up to 95 to 98% of the MDD value, which is maximum dry density value. That has to be achieved. So that in future, I cannot say that problems will not come. You are trying your best to reduce the problems by doing this.
So we also use waste material in our road construction works, where we have the high embankment filling.
Okay.
So in those area, what should be the minimum height up to which we should fill that material, and what should be the maximum height of the soil above it with the proper soil?
See, basically, as we are doing the controlled compaction, we need to make sure only every 300 mm you need to compact it. And whenever you are thinking that this particular problem is going to happen at the site, we will try to arrest the entry of water into the soil in that particular area.
Can we use Pondas as a substitute material, because it has a very thin particles, and that can fill up the voids?
But it has the more probability to wash away also when there is an entry of water. So you make sure that entry of water has to be stopped from your side due to any means.
Okay, thank you.
So much, sir, for such
Thank you.
wonderful insights. Now I would request our Honorable Director, sir, to please present the token back to you to Professor Ramesh Vandanapu, sir.
कैसे निकालना है?
Actually, it's Ajit Uswal is here. So
लिंक दिया है ना हमने, लिंक आप लिंक कनेक्ट कीजिए वो वेबएक्स में, वो तो वहां से कनेक्ट कर लेंगे ना, दे विल क्लिक एंड कनेक्ट। पीपीटी भी खोली है, उनके बारे में पढ़ना पड़ेगा ऑनलाइन पे। अब बात करिए
okay, मैं करता हूँ. You can click on the link, then we'll guide you. Okay, he has clicked the link.
मैसेज ज्वाइन
Have you Are you able to see someone? Board. I say. I say. It is showing. You can. I'll just put on 1 minute. It is saying that when host will join, you can join like that. It is.
You send the same link you sent to Professor Reddy.
Yes, I had sent him the link. But
The same link will work.
यहाँ पे सर ऐसा कोई रिस्ट्रिक्शन है नहीं ओपन मीटिंग में
He might
Uh,
join some other session.
I say 1 minute. Then we have to send. Can you send me on the WhatsApp the link? Then I can.
Just
You send me. I'll forward him on this.
सर ये लिंक है सर ये वाला
link.
वो लिंक दे दीजिए ना हमें. ऐसा उनको फिर से भेजेंगे क्या? उधर
WhatsApp नहीं, अब मेल खोलिए, मेल खोलिए.
1 minute. I will.
ये आपको भेज दूं, आपका मेल इसमें है ना?
हाँ मेरा मेल
What's your
है.
email? अब अपना
RM
मेल है
भाटोड़ेकर.
ना?
हाँ मेल है, मैं फॉरवर्ड कर. भाटोड़ेकर BHATAWDEKR
के
DEKR KAR @gmail.com. मैं उधर से तुरंत भेज.
उधर से उनको लिंक भेज दीजिए.
इंट्रोडक्शन रीड करना है सर.
आप तब इंट्रोडक्शन रीड कर दीजिए. कहाँ है?
वो खोलना पड़ेगा.
अगला.
कट इसको कॉन्फ़िगर कोई क्लोज मत करिए.
हाँ क्लोज नहीं किया है वो पोर्शन क्लोज किया. चलेगा. So, welcoming our next keynote speaker, Mr. Iit Ostwal, Head Mines at Ultratech Cement Limited. Mr. Ostwal holds a degree in mining engineering from MBM Engineering College, Jodhpur, and earned his MBA from U21 Global University, Singapore in 2007. He is currently serving as the Joint President and Head of Mines at Ultratech Cement Limited, located at the head office in Mumbai. Additionally, he serves as the chairman of the Mining Committee for the Cement Manufacturer Association and is a member of the FICCI Mining Committee, Cement Committee, and FIMI Managing Committee. He holds a position as a Managing Committee member of the Coal Preparation Society of India. Mr. Oswal commenced his professional journey as a graduate engineer trainee in the cement division of L&T in the Chhattisgarh unit. Possessing a first-class mine manager certificate, he has a rich background in mine planning, operations, equipment planning, introduction of new technologies, digitalization, cement plants planning and budgeting, quality and environment system management. He is also a lead auditor in EMS and a master black belt in Six Sigma. He has actively contributed to the development and operationalization of greenfield limestone mines and underground coal mines. His involvement extends to limestone block bidding, limestone capacity expansion, and merger and acquisition activities. Mr. Otswal has played a key role in various due diligences related to limestone, coal, gypsum, bauxite, and cement, both in India and overseas. In the course of his assignments, he has traveled to South Africa, Mozambique, Botswana, Madagascar, Egypt, UAE, Philippines, Oman, and Singapore. So please welcome Mr. Iit Otswal, sir.
He's joining online. Just 1 minute. वही लिंक भेजा है ना आपने? सेम
वही भेजा है. यही है. ये है. वो व्हाट्सएप में भेजा।
फिर यहाँ उनका मेल आईडी भी डालेंगे तो अभी भी चला जाए।
कहाँ पे बताइए?
ये इनवाइट इसमें सब मेल
उनका ओसवाल जी का मेल आईडी क्या है? हाँ, यस।
ओके, ठीक है, ठीक है।
करिए।
Hello, Mr. Ajit Oswal. Welcome to this ICGID conference. Are you able to see us?
Yeah, I can see.
Okay, okay. Now, are you going to have presentation or you will be?
Yeah,
Uh,
I will have presentation.
Okay, so you can share it actually. Means
Okay.
there is a share button, so through that you can share it. Okay.
Okay.
Okay. Thank you. Okay, okay, ठीक है. Okay, okay, ठीक है. चलो अभी
कैमरे
चलो, okay, ठीक. Mr. Ajit Oswal, are you sharing the presentation?
Yeah, I will. I am sharing. I will just trying to share the system.
There is a share button at the bottom.
Yeah.
third.
I link the share button, then go on to window. Just a minute. Where exactly it can?
It is-
You allowed sharing from my system?
Yes, I think. Yes, it is
Eh,
allowed now.
Because this my computer, I'm unable. I'm seeing the Microsoft Edge tab, Window tab, an entire screen.
Entire screen you can share.
But this share is not enabled actually. This share is
Ah.
showing disabled actually.
Actually, huh? Okay.
You have to select the entire screen tab button.
Yeah. I have selected the entire screen tab button. Okay, just a moment. Now I think.
Now something has.
Are
Yes,
you
yes.
are you
Now,
able
yeah.
to see?
Yes, we can see. Yeah, thank you.
Okay. So I am audible. Am I audible?
Yes.
Okay, just give me one moment. So, very good morning to all and wish you all very happy new year 2024. So, dear professors, students, fellow speakers, industry experts, and participants to the conference. Thanks, distinguished Professor T.N. Singh, Director Iit Patna, and Dr. Ramesh Bhatwedkar for inviting me to this August forum. I'm supposed to be physically present, but due to flight cancellation, missed the opportunity to speak to you all. I'm thankful to Ultratech Cement Management, more specifically our Chief Manufacturing Officer and Business Head, Mr. E.R. Rajnarayan, who has been inspirational and guiding force in our endeavor of excellence in every sphere of cement manufacturing and new project execution, including mining. The conference theme is geotechnical issues in energy infrastructure and disaster management. I will focus my talk on one of the key elements of infrastructure, that is cement and mining. So just to give a brief overview about the Aditya Birla Group, Aditya Birla Group, as you know, is a premium Indian conglomerate, premium global conglomerate with 63 billion US dollar market cap. Having business, it is the largest cement player. Ultratech Cement is the number one cement player in India and third largest cement player globally, excluding China. Other business of Aditya Birla Group is that we are second in viscose staple fiber globally and number one producer in specialty chemical, caustic soda, and advanced material in India. Hindalco, our other group company, is the number one in aluminum rolling globally and world's most sustainable and largest recycler of aluminum. Fashion and retail, we are top fashion retail lifestyle player in India. Aditya Birla Group is also a leading financial service player. Second largest in carbon black producer. Uh, World leading Swiss Singapore, which is our world leading bulk commodity trading solution and logistics provider. Similarly, on ferroalloys, Eshel Mining is the largest domestic producer of high quality noble ferroalloys and leading MDO in Indian private sectors. And Century is the formidable player in real estate with more than 6.4 million square feet under construction. And as a telecom player, you know that it is a leading telecom player in India. So coming to the Ultratech Cement, that cement is the third largest cement player excluding China and largest in India. We are also largest RMC manufacturers in India with 250 plants. Another aspect is that Ultratech have Ultratech Building Solutions, where different products of building material are provided to provide complete building solutions, having 3,577 stores. Birla White is a niche cement where putty market. Uh, so uh, consolidated revenue of 7.9 billion US dollar. We are, I mean, every year we ship or manufacture 2.1 billion bags of cement, and there are 90,000 plus direct and indirect employees Ultratech having. In terms of diversified portfolio, our capacity, cement capacity, which is gray cement capacity, is 137.85 million ton. First cement plant was established in 1983. In white cement category, there are different products which are available. RMC are having different offerings in terms of decor, floors, Duraplus, Rapid, etc. So different offering from ready mix concrete. Building solutions, these are the outlet. This verticals, this segment was started in 2007 and growing, rapidly growing. And similarly, building products division, which is started in 2012, having more than 60 products in its portfolio. So if we see our journey of growth, the first cement plant was established in 1983 uh, when at Vikram Cement and Rajashri Cement in Karnataka. Two plant were established. Then 1999, 1998, the Indian Rayon plants were merged with the Grasim Cement, and the capacity becomes 9.6 million ton, 8.5 million ton. Then in 2004, we acquired this L&T cement business of 17 million ton, and thereby capacity become 31 million ton per annum. We focused on the least cost producer, on the cost leadership, synergy of cement business. Investment in thermal power plant was started in 2008, and now 80% power we produce our own power. Then next phase of growth was organic capacity addition of 15 million ton. And we also acquired Star Cement based in Dubai, Ras Al Khaimah area. So one integrated plant and grinding units. In 2016-17, we acquired this JP Cement, cement assets, Binani Cement, Century Cements. Thereby, the capacity went to 120 million ton. Recently, we commissioned 12.4 million ton greenfield brownfield capacity. Their capacity become 2.4. So current growth phase, we are expanding capacity, and after this expansion, which is already undergoing, our capacity would be 165 million ton, and by 2027 we would be achieving around 187 million ton per annum. So this is our growth journey in terms of cement capacity. As on date, our cement capacity is 137.9 million ton per annum. So Indian cement sector, if I explain that Indian cement sector, so just to have a proper perspective, this is the mineral baby, which shows that every American born, America is the developed country, and every American born will need 3.07 million pounds of mineral, metals, and fuel in their lifetime. And cement is one of the major component. 60,000 plus pound cement he will consume in his lifetime. Similarly, other mineral like clay, coal, copper, gold, iron ore, lead, lithium, phosphate, and other minerals. So this is just to give a perspective in terms of since India is also on growth path of becoming 5 trillion economy, and then further moving to catch up to developed category. So our consumption pattern in future is going to be similar that of USA. Similarly, if we translate that in the yearly need, so every year 40,209 pounds of new mineral must be provided for every person in United States to make the things we use daily. And cement here also 794 pound is the cement consumption every year a person require. So we will also have aspiration to reach these levels. So now come to the global cement, what is the per capita consumption. So if we see the various countries per capita consumption, China is around 1430 to 1480 kg per person, whereas if we see India, it is 280, whereas the world average is 500 to 550. So there are a lot of catch up which we need to do with the world average, and of course, I mean other developed countries who are there, their capacity per capita consumption is much higher. So in terms of cement capacity, if we see that China being the largest producer, producing almost 50% of world cement. India is the second largest producer. I mean, we are ahead than the United States of America. So India's production share is 32.33%. So second largest player. So in terms of cement industry growth, if we see year on year basis from FY11 to this FY23, FY11 it was 214. So this cement growth is directly linked, more or less linked with the GDP growth rate. And current capacity FY23 388 million ton, and FY27 we are projecting to produce around 500 million ton, and FY30 projection is 610 to 620 million ton. So we'll cross around 600 million ton by FY30, which would be 1.5 times from current level. So all the growth in cement is inevitable. So what are the major demand drivers for the cement? One is, of course, rural housing is one of the important demand driver, which currently is 37%, which is going to be 33% of total cement sale. Then urban housing is another major driver for cement consumption. currently 30%, which would be around 28% going forward by FY30. Infrastructure is another source, as India, a lot of infrastructure is being built throughout the country. So infrastructure from current 24% share to it will go to 29% share, and industrial and commercial segment would be around 9%. So these are the four key driver for cement demand. If we see UltraTech landscape, how UltraTech, so if we see the cement plant is similar to a mineral industry, because we use all sorts of natural resources to produce cement. So main component is limestone, which is a calcareous limestone, or some amount of chalk, marble, or sisal is also utilized. Then we also need some clay component, silica component, so that comes from this argillaceous nature of natural resources. So it will come from clay, shale, marl, and soil. Some additive would be required in terms of supplementing Al23, Fe23, so laterite, bauxite, iron ore. This would be required in terms of clinkerization. Then gypsum, fly ash, slag, this would be required for addition to the cement grinding, so that we produce blended cement. And fuel, of course, coal, petcoke, or alternative fuel and raw material is also utilized as a fuel source. So most of the raw material are naturally formed or mined, which can be discontinuous, heterogeneous, and making the chemistry variable. So if we see limestone resources in India, you will see that limestone is found in 10 to 12 states actually, and it is in clusters. So if we see, this is the central cluster in MP. In Rajasthan, you will find the limestone. In Himachal and Jammu Kashmir, there is some amount of the limestone. Chhattisgarh, Andhra Pradesh, Karnataka, uh, Gujarat, of course, coastal Gujarat, it is there, and Tamil Nadu, some amount in Tamil Nadu. So these are the Telangana also, Maharashtra and Telangana also. So if we see that India have a 227 million ton resources of limestone of different geological age, but reserve is only 8%. Reserve means which can be mined. Mineability is ensured from environmental perspective, quality is ensured from usage perspective. Resources are which are logged in some or other constraint and need to be converted into the reserve through more exploration, through removal of various constraints. So cement grade limestone is 70% of total limestone available. If we see the limestone resource distribution state-wise, we'll see that Karnataka is the largest limestone resources. It have a 24% share of limestone resources. Andhra Pradesh 13%, Rajasthan 12%, Gujarat, Meghalaya, Telangana, Chhattisgarh, MP, and other states are 15%. But if we see production capacity of different state, we'll find that Rajasthan, though resource is 12%, production is 19% of total production. Similarly, Andhra Pradesh produces 11%, and other states like MP, Chhattisgarh, 12%, 11%, etc. is present. So some of the states like Rajasthan, MP, and Chhattisgarh are exploiting more proportion in comparison to their resource share. And total limestone which is being produced in India, 97% is cement grade limestone, and rest 3% is steel grade, chemical, and other limestone which is there. If we see UltraTech India footprint, so we are almost present in all the states except Jammu and Kashmir and Northeast. All others. So we have a 24 integrated units. Integrated units means units where there would be a mining leases would be associated with the units. Grinding units are places where clinker is brought from the mother plant of integrated units, and fly ash and slag addition is done. So these are 29 grinding units. We have 8 bulk packaging terminals. So here the loose cement is packed, which is transported either through sea route or rail route. Also, we have 1 white cement and 3 putty plant and 5 number of jetties on the coastal sides. So if we see the capacity, ultratech capacity in terms of different zones, north, central, east, west, and south, we are having around 20 to 30 million ton in each zone, so totaling 132 million ton, and overseas 5.4 million tons, so 137.9. The UTCL market share is varying from 11% to 37% in different zones. So overall basis, this is 22%. Overall industry capacity is close to 600 million ton. So end to end, we have an end to end capability of with integrated operation like raw material. So key input, limestone is the key input for manufacturing cements, and 100% sourcing is done from our own captive mines. Long term, these mines are granted on long years mining leases. Petcoke, gypsum, iron ore, fly ash, slag, etc. is procured from open market. We have 1 coal mines for our captive consumption, but rest of the material, I mean fuel, we source from the market. For captive power generation, we have a 1188 megawatt of power. WHRS, which is West Heat Recovery System, windmill, solar power is 691 megawatt, and this is the production capacity which we are having. In terms of transportation, if you'll see that the logistics, we are having combination of rail, sea route. So coastal plant from Gujarat brings material to the south, Kerala and Karnataka coast, even the Maharashtra coast. Similarly, there are inland water transport also very recently it was initiated. So if we see the total transportation mix, through road transportation, 74% is transported, 24% through railway, and rest 2% through sea. And 11,000 plus trucks are loaded per day. We have more than 42% dedicated fleets, 6 specialized carrier, mini bulk carrier, and 1 coal ships. 39 rakes are loaded per day. 1,27,000 channel partners and 1,300 plus warehouses and 275 railheads we are serving. So cement, if we see that what is the cement manufacturing at a glance, we can see. So first and foremost activity is the quarrying or limestone mining, which is being done. Then the material is crushed into the limestone crushers. Then it is homogenized in the stockpiles. Then it is grinded in the raw mill grinding. It is grinded grinded to a powder form, and then stored in the stored, and then the pre-calcination takes place in the preheater. Uh, and this is the heart of the cement plant, pre-calcination and the kiln, where the from one end fuel or coal is fired, and from other end this limestone comes, and the actual calcination happens at 1200 to 1300 degree temperature, and the clinker, which is the intermediate product, get formed, and the clinker is stored in the clinker silo. And then here, while cement clinker is grinded into cement, we add fly ash, which is maximum permissible is 35%, and slag can be added to the as high as 55 to 60%, and then it is stored in silo and dispatched from the plant. So this is an in nutshell of cement manufacturing at a glance. So if we come to the limestone mining part, so limestone is the main component of the raw mix, where the 85% to 99%, I mean different cluster of limestone will have a different quality. So somewhere, I mean, even the limestone which is available like Chhattisgarh, etc., it is 100% raw mix. I mean, there is hardly 1% addition is required. But some of the southern plant or even north plants where we need to add iron additive or alumina additive, etc. So then there 85% is the limestone component. So it is all sourced from captive mines. Uh, all limestone mining follows the open pit mining, as most of the mineral or limestone is available at shallow depth. I mean, maybe up to 100-meter depth we are operating. The open pit mining involves the drilling, blasting, loading, hauling, for which heavy earth moving equipments are deployed. For mineral deposits which are soft in nature, drilling and blasting is replaced with the non-conventional mining. Like in Gujarat coastal area, 3 units we are deploying the surface miner, where it is using only cutting technology, and in some of the constraint area we also use rock breaker. For mine planning, the key strategic aspect of mining would be the optimizing the available
Sir,
limestone.
sir, we have to wind up quickly now because we are breaking for tea. So,
Okay. Yeah, yeah.
in
I will wind up within 2-3 minutes. Sure.
okay, sir. Thank you. Thank you, sir.
Yeah. So, so for resource evaluation, we are using the mine planning software like DataMine, Survey, AutoCAD, Global Mapper, Icgeid software. Drone survey and analytics are used for operation and planning. Mine capacity ranges from 1 million ton to 14 million ton per annum with low stripping ratio around 0.3%. 13 of our mines were rated 5-star category in FY 2022. So if we see what are the geotechnical application in mining, the limestone mining, if we see the exploration, when we do the exploration, geotechnical parameters are very, very important. Drilling, even drilling planning, blasting planning and its execution, these parameters plays an important vital role. Bench design also, it plays an important role. Overall pit slope, specifically in the hilly area, geotechnical parameters are very, very important. Over and dump designs and slopes and environmental management. So these are the some of the areas where geotechnical applications happens in limestone mining. We are also operating one coal mines, which I will just give a brief that in the exploration stage, all geotechnical parameters like RQD and other parameters we derive for design of underground coal mines. Inclined drivages and shaft sinking, this is also very important. Then roof support, that what kind of support mechanisms should be there in the board and pillar operations. So there also it plays very, very important role. And water ingress impact also, geotechnical parameters are important. So this is just a pictorial overview in terms of exploration, where the core drilling is done, and to assess the quantity, quality and availability of limestone deposits. These are the various steps of geological exploration, from survey to chemical analysis. Then data are processed in the mining software, geological models are created, pits are created, scheduling happens. So, and blasting, I mean, explosive rock property and blast design property, here also geotechnical parameters plays very, very important role. This is shown a pictorial view of blast design. Underground coal mines, we have one underground coal mines which we have developed from the greenfield and currently producing 0.75 million ton per annum. We have deployed the latest technology of cutting. We are not doing any drilling and blasting.
Mr. Ajit Oswal,
Yeah.
will you please summarize the last portion, because
Yeah,
other
yeah.
presentations are.
Yeah,
Thank
yeah.
you.
So, okay. So I will. So this is just a brief overview about the underground coal mines and digitalization initiatives. Thank you so much. So the application part, I have already explained that some of the operations of like drilling, blasting, exploration, slope design, geotechnical parameters we are utilizing, and this is all about my inputs and presentation. Thank you. Thank you so much.
Thank you. Okay.
Thank you, sir, for this nice talk, enlightenment talk. And we have a memento for you, but unfortunately you couldn't come. So we will hand it over to Dr. Ramesh. He will give you there. Otherwise, we'll send by post also. No problem, sir.
No, that's fine. Thank you so much. It was my deep desire to come to Patna, but somehow could not make it. But of course, next time we'll have a Thank you so much.
Thank you so much, sir.
Thank you.
Now I would request everyone to enjoy the tea break and be back please after 10 minutes.
खोल के देख
बायोग्राफी मैनेजर चाहिए आपने कर दिया था
धूप आ गई अपनी इतना ब्लास्टिंग कराया क्या So their director also was saying to have conference in Bali, so I'll see how it can be organized. Bali, their director, Professor Mitra, Kemper, we are suggesting to have conference in Bali. So it will, next year, I mean, the end of this year, I'll organize. Last November, just after Diwali. Yes. Because of India, and then Bali is a good place, and its accommodation is also not very costly. It's other places. Indians, a lot of temples are there. Sightseeing can be done.
have sent the product.
बोला तो सभी कंटिन्यूएशन में इसको कर देते हैं इसको मैंने बोला वही ओके इसलिए मैं हाँ ये वो बोले हमारा सर हर्षद हाँ हाँ हो अभी सर फिलहाल तो अभी एक जम्मू में साइट है एंड अभी सिक्किम में सिक्किम में अभी बर्फ के कारण अभी बहुत प्रॉब्लम है ये साइड पे अभी बर्फ आ रहे हैं वहाँ पे अभी मॉर्निंग से उसी चक्कर में पड़ा हुआ है प्रणाम सर कैसे कल तो गवर्नर तुम्हारे आ रहे हैं अभी हम लोग इस चक्कर में ही फंसे हुए हैं एंड अभी नालंदा वाले जो है नालंदा ब्रिज कॉन्फ्रेंस है उनका भी एक काम है तो उस चक्कर में भी थोड़ा लगे हुआ पापा ने बोला तो बस जाकर सर से एक बार मिल लेना इसलिए हमारे लिए तो सौभाग्य की बात है आपसे मिलना
यही
आज एंड कल ओके सर मैं कल भी आ जाऊंगा अभी मैं 24 तक पटना में बहुत कुछ सीखने को IIT is a big thing for us अभी एक दूसरे से सीखते हैं जो आप जानते अनुभव है वो उनके कैसे एक्सचेंज ऑफ नॉलेज ये का प्रोग्राम रहता है सब दिक्कत हो तो बताना मेरे सर मैंने अभी जस्ट बीटेक अभी मेरा कंप्लीट होगा ओके ग्रेट मैं पारुल यूनिवर्सिटी वडोदरा गुजरात से हूँ
किसने दिया था
हाँ यस मेरे बस इसका ब्लड ठीक है मिलते हैं फिर सर डेफिनेटली मिलते हैं मैं यहाँ पे
प्रणाम सर कैसे हैं आप
सर इसको 26 में करते हैं क्योंकि आप है ही नहीं तो फिर बुला के मैं ऑलरेडी नहीं ठीक है तो आप बहुत शॉर्ट पे भी हो जाएगा वो तो यही आए हुए हैं कि आपको हमारे साथ ही चलिए लेकिन आप प्रोफेसर यही आए हो आप उधर एक टलते टलते दूसरे स्टूडेंट का तो 2 हो गया है टाइम तो जाने नहीं हो गया आज ये 26 को तो है ही ना सर उसी को फिर सर्कुलेट करना है ठीक है थैंक यू
कैसे हैं सर आप
बढ़िया ये कल से लगे हुए हम लोग
हाँ हम भी सरप्राइज हो गए आपने कहा था आप फ्री होंगे बट लगता है कॉन्फ्रेंस आ गए
हमारी
अच्छा आप ही
डायरेक्टर सब्जेक्ट
करेक्ट
आपके पास दिन में कभी 10-15 मिनट मैं निकल के ऑफिस आता हूँ तो आपको कॉल। ठीक है सर, हम यहीं पे कैंपस में हैं। एक अर्जेंट मैटर है सर, वो बच्चों के एग्जाम के रिजल्ट में बहुत
अब आते हैं तो बात।
उत्पाद मचा हुआ है, तो उनका थोड़ा गाइडेंस चाहिए था सर।
नहीं, वो कुछ नहीं कर पा रहे हैं। Need resource.
अभी आसिफ सर से नहीं मिले, वो बोले बस सर से गाइडेंस ले लीजिए।
Actually, when the problem is shared, उसी समय बोलना चाहिए। उसको क्या पढ़ने के लिए why they are delaying so much? इनिशियल स्टेज में लगता है कि हर्डल है, बोल देते 15 दिन पहले जो काम होता है जो 15 दिन बाद होता है। It matters for a student.
Yes.
ये चीज
Well, greetings.
अबे स्टार्ट करा दो ना। हाँ, बुलाना पड़ेगा। नहीं नहीं, आते रहेंगे लोग, ऐसा थोड़ी होता है। चाय बोलो तो सबकी चाय
बाहर अनाउंस कर दो।
हाँ, तो मैं तो आपको फोन करता हूँ।
हम यहीं पे हैं, तो आप वो लाउंज में वेट करेंगे सर, आप
वेट करिए, जहाँ भी रहिएगा। आई विल जस्ट कॉल यू। आप 10-15 मिनट में आ जाए, सब कॉल करूँ और
ठीक है सर।
यू सी अदर वर्क।
ओके सर, थैंक यू। नाम बताइए।
ओके।
इसमें हाई टेम्परेचर
सर ने इंटरनेट की स्पीड का बहुत इशू बना है। इंटरनेट स्पीड कोई देखते हैं कि आ रहा है।
कहाँ है वो?
सही करना पड़ेगा।
सर वो फॉल्ट रहा है, ये नया
कल भी
क्यों भाई, क्या दिक्कत है?
मैंने कोई देखने नहीं आया यहाँ।
इधर का एक्सेस ही हमको अभी तक मिला ही नहीं। कौन है? सर अजय और हमारे जो अर्पित सर, कल भी नहीं। तुमको दोनों को पहले बोलो कि मैं बुला रहा हूँ इमीडिएट 5 मिनट के अंदर। बेस्ट बी प्रेजेंट हियर। बोलो, नहीं आते हैं तो मैं बताता हूँ। क्या मजाक बनाए हुए है क्या? बोल भी रहे आप, सीधे बोलो कि मैं बुला रहा हूँ, और जहाँ भी है सब काम छोड़ के यहाँ।
स्पीड तो अच्छा है सर, नया वाला जो सेंसर जो है ये पहली बार आया है सर। ये डायरेक्ट लगाएंगे आप, डायरेक्ट बेस मिल जाएगा। उसको सर्च करना पड़ता है वेव फॉर्म में, वो नहीं करना पड़ेगा।
डिजिटल वैल्यू देगा,
डिजिटल वैल्यू देगा सर,
और ग्राफ भी
देगा सर। तो ये है सर, ये पीछे वाला लैब
वो इसी पे काम कर रहा है ना तुम्हारा इसको जल्दी कराओ यार, टाइम है। साथ वाले साहब जब हम लग गई है बेचारे।
सर, वो टाइम ही नहीं दे रहा है आने के लिए। टेस्टिंग पूरा बचा हुआ है।
हाँ, पूछा था उससे कि तुम ऐसा कर रहे हो सर, ये अच्छा नहीं लग रहा है कि कोई चीज बहुत परेशान होगी। इसको जल्दी करा दिया जाए, फिर उसका अपना भाग्य जहाँ है। बेसिक बुला, उसको बुलाओ। क्यों नहीं टाइम दे रहा है? कॉल पर ठीक है। हाँ, और चाय नहीं पिए तो पी कैसे? हाँ हाँ हाँ,
आप सेंट्रल
त्रिवेदी का कुछ काम आता हाँ, वो
और हम लोग डिस्कशन कर रहे थे 9 मंथ का जो स्किल पर ट्रेनिंग पोस्ट ग्रेजुएट डिप्लोमा का, तो इनके तरफ से ये ऑफर था, तो आपसे डिस्कशन भी किया था। ये सिलेबस रेडी है या फिर रेट बना के देंगे?
बस रेडी है, आपको अगले
पहुंच जाएगा
तो जनरेट किसी एक्सपर्ट से 2-3 से
ये तो करवा लेंगे सर।
टाइपिंग ये भी बता देंगे कुछ एक्सपर्ट जो उस जगह में काम कर रहे हैं।
वो फिर आप
ओके,
क्या हुआ भाई?
आ रहा है?
ये वाला वीडियो सर सब हमें जानना है से बुला रही है सब लोग
वो ऑनलाइन है कि सर का है? आपका है। पीपीटी तो पहले सर का में तो इशू नहीं है ना? सर वाला पीपीटी कहाँ है? वो फर्स्ट, हाँ बस ये पेज को करके छोड़ो बस।
इस पेज और
फर्स्ट पेज करो ना जिसपे वो डिटेल है। हाँ तो लोगों को बोलो कि
आप स्टार्ट कर दीजिए हमारा।
चलो मैं जस्ट इनवाइट जो हमारा है फॉर्मेलिटी करो, इंट्रोड्यूस करो जल्दी से सब।
So, in the continuation of this keynote sessions, now we would like to welcome Dr. Rajneesh Kumar Goyal sir, former professor and chief scientist, tunnel and underground space design, CSIR CIMFR, Roorkee, Uttarakhand, India. A distinguished and internationally acclaimed scientist, Dr. R.K. Goyal, during 38 years of his relentless and dedicated service to the nation, provided consultancy to more than 60 tunneling and mining projects and solved the problems related to design of tunnels through varying and challenging weak and fragile rock masses, such as in the Himalayas. He is an editor of the reputed General Tunneling and Underground Space Technology. Dr. Goyal has co-authored 5 books, the latest one on underground infrastructures, planning, design and construction, published in May 2012. His books were published by Elsevier Limited and A. Balkema. Book on engineering rock mass classifications has been translated in Korean language by South Korean Publishing Agency. He has formulated 6 BIS codes and designed, developed and patented 3 instruments for the monitoring of tunnels and underground structures. Dr. Goyal has published more than 150 research papers in peer-reviewed national and international journals and conferences. He is editor of Tunneling and Underground Space Technology, TUST, a journal of Elsevier Science Limited. He is editorial board member, ISRM India Journal and editor, Journal of Rock Mechanics and Tunneling Technology, a biannual journal of ISRMTT since 2000. In addition to various research awards of IGS, CSIR, CIMFR, IIT Roorkee, he has also received the highly recognized Ministry of Mines, Government of India's National Geosciences Award 2004 for his outstanding contributions in engineering geology. He has received ISRMTT Award for outstanding contributions in rock mechanics for the year 2007, IIT Roorkee Gopal Ranjan Research Award 2012 and ISRMTT Lifetime Achievement Award 2021. Please welcome him on stage.
Good afternoon. At the outset, I should thank Professor T.N. Singh, Dr. Amit
for inviting me for delivering this keynote lecture. I have selected a talk on rock bolt grouting and improvements in rock mass quality in tunnels. So I will be mainly concentrating on how we can expect the improvement in the quality of the rock mass because of the grouting which we carry out in the full column rock bolt in the support of the tunnels. So now, with the introduction, you see, pre-grouting is generally required to be carried out in very weak rock masses. When we excavate a rock and if it's a very poor rock having less stand-up time, so what we have to do? We have to pre-grout it, or we have to have the 4 poles as the support. So in NMT, Norwegian method of tunneling, they emphasize on pre-injecting or pre-injection grouting in the very poor rock masses. So the very poor rock, these are required for improving the rock mass quality before the tunnel excavation. And you will understand that it also acts as a sealing agent in water charged rock masses. Now the thing is that it is understood that like the pre-grouting, the grout of full column grouted untensioned. So I have mentioned here the untensioned rock bolts because this will act really as the active support when it is grouted. Rock bolts shall also help in improving the rock mass quality. So this has been emphasized by Sun et al. In 2012. So picking this point from his just the statement, I have tried to study a bit about this, that how the rock bolt grouting can influence the rock mass quality surrounding the tunnel excavation. So what we can really presume that improved rock mass quality shall help in reducing the ultimate pressure for which we have to design the supports, right? So the study presents the improvement in rock mass quality suggested by Barton. So what I have done is that how various parameters of Q may be influenced because of the grouting of the rock mass. Now, as the background work, you might have seen the work carried out by Barton, that what will be the effect of pre-grouting in the improvement of the rock mass quality Q. So grout material when percolates through the cracks, joints and fractures, these fractures can be during the tunnel blasting, the excavated damaged zone, which can be around 1 meter around the tunnel opening, and it may be more if you have uncontrolled blasting. So Barton et al. In 2001 and 2002, they have shown the improvement in Q value, but that was limited to very poor quality of the rock mass, and the reasons for the improvement which they have cited or they have mentioned are that the filling of joints or the voids because of the percolation of the grout, then closing of secondary joints or fractures, gluing and strengthening of part of the rock mass. So how it is going to affect? Gluing means you are in fact reducing this number of joint sets, right? In case of JN, in Barton's Q, or the gluing means when the joint sets are reducing means you are improving the RQD. So similarly, other parameters are also influenced because of the pre-grouting. So reduction of water flow and the resulting improvement in excavation conditions and reduction in the rock support requirement, such as rock bolts and the shotcrete. Now, then in his publication, he has shown that how these qualitative effects, which has been shown in the earlier one, can influence the Q value. Now, various parameters of the Q, RQD, he has suggested that there can be increase in about 30 to 50% of RQD, depending upon the original rock mass condition, depending upon the presence of the fractures, the joints, and other discontinuities. Then the JN, it will reduce to 9 to 6. Now, some of you who are not familiar with the Q system, they will think of as when the JN is reducing, then how the quality of rock mass is going to improve. But you see that Q is equal to RQD upon JN multiplied by JR upon JA multiplied by JW upon SRF. Since JR is in the denominator, so reduction in JN will ultimately helps in improving the Q value. Similarly, now you see the JR, what they have suggested that there can be increment in JR from 1 to 2. JA, joint alteration, the alteration of the joint surface because of the weathering, it can reduce from 2 to 1. Similarly, JW effect and the JRF effect. And you see, when he has suggested that increase or decrease in individual parameter, as I have shown in the upper one, it is small, but combined effect is considerable. For example, Q value increased from 0.3, which is classified, the rock mass is classified as the very poor. 0.32, it can increase to 16.7, which is a good rock. So you see, the pre-grouting, that's why they have suggested pre-grouting in NMT. They have emphasized pre-grouting very much in their Norwegian method of tunneling. Now the range of Q, which I have considered for this study. In this slide, I am just discussing the basis that why I have selected that particular range of the study. Now, pre-grouting, as has been emphasized, is generally carried out in poor rocks having Q less than 1. In tunnels, no or less blasting effects are expected on rock masses with Q less than 1 because it is already highly jointed. So blasting effects are not going to be much in that because of the blasting rock mass is not going to be disturbed much. So therefore, Q less than 1 is not expected to be affected by the blasting. Similarly, Q more than 40 is also not going to be expected much because of the blasting, because Q more than 40 is about the very good rock mass. So massive and tightly jointed rocks with Q more than 40 and span more than 20 may not require regular rock bolt support also. And therefore, since I am discussing about the effect of the rock bolt grouting in the rock mass, so I have confined my study between Q less than 40 and more than 1. And you see, in pre-grouted rock mass, full grouting of rock mass help in improving the Q value. Now, how it is going to improve? First, just schematically, rock bolt grouting in 3 to 4 steps. Just schematically, I have shown one exposure of the rock mass and one outline where we want to have the borehole and to install the rock bolt. Now you see, we have drilled the borehole, and then we have installed the rock bolt and we have grouted it by the cement grout. Now you see, we expect that the grout will percolate through the cracks of the rocks around the rock bolt, right? Now you see, we have number of bolts. We have number of bolts, okay, at regular spacing, and spacing is depending upon the rock mass, quality, Q value. Now you see here, this grout is percolating. This is the grout, percolated grout. Okay, here it will be more because of the gravity, and here it will be less. Like this, since we have number of bolts, so that means we will have a grouted zone around the tunnel and along the rock bolt column. So tunnel excavation result in the widening of joints and creating new fractures near to excavated periphery, like excavated damaged zone. So it is expected that these type of zones, the grout will percolate through these fractures, and so we can have a grouted zone. So rock blocks will get cemented. So as I have told you earlier, because of this, how is it going to reflect the Q? That means RQD again shall increase around the tunnel. And you see, after the blast, what we do? As geologists go to the face, map the geology, map the joints, okay? After that, he calculate the Q value, and then the support is decided. So that means when we collect the Q, the rock mass is also damaged because of the blasting, or because of the, because of the loosening of the zone. And we have seen then in Q from 4 to 1, because of the stresses mobilizing from the face towards the tunnel, there are chances of some cracks because of the loosening of the, because of the mobilization of the stresses. So those cracks on the roof also are going to be cemented because of the rock bolt routing. So we expect the improvement in Q value. So qualitatively, I have tried to, study each parameter, that how the rock bolt full column grouting is going to affect the parameters of Q, and how ultimately it is going to improve the Q value. Now what I have done is that I have taken 4 classes of rock here. One, the poor rock, represented by Q from 1 to 4. Second one is fair rock, represented by Q 4 to 10. Third is good rock, represented by Q value 10 to 40. Because I have the limited, I have confined my study from Q1 to 40. Now you see the variation in each parameter, right? It's mentioned here. And you will see in the good rock, the variation is less. The minor change in JR, JA, no change in JW, because joints are tight there. So it is not affected that grout will percolate, because as the rock quality is improving, the joint conditions and other things are improving. So the grout will not percolate much. So therefore, the effect of grouting is expected less. So expected effect on Q is shown qualitatively. Effects may be more, and because some of you are students here, so this study, it's just a preliminary study which I have carried out. Some of you can pick it up, and you can still be studied That's why I mentioned here, it should be studied further to more crystallize the idea. Now, what should be the modified Q then? Because which I have shown in the earlier slide, the modification in various parameters rating. The original Q value 1 to 4 in first column. The modified Q value can be 3 to 10. So 1 changes to 3 and 4 to 2.5. So as the improvement is there in the Q value, the effect is less. With this logic, this has been studied and prepared. Now, similarly, you see in the good rocks, when 10 to 40, good rocks 10 to 40, the improvement or the modified is 20 to 40. So in case of 40, no influence of pre-grouting, rock bolt full column grouting is expected. Now you see the bolt spacing, if we pick the bolt spacing, because the main thing we are discussing here is the bolt spacing and the grouting effect because of bolt. Now bolt spacing, we pick up from the Grimston and Barton support chart, which I will show you in the next slide. So the bolt spacing for Q is equal to 1 is 1.5 meter. Now what I am suggesting here is that we will keep the bolt spacing as has been suggested, as has been obtained using the original Q, because ultimately the grout of the bolt is going to affect the rock mass. So we will not consider the Q modified. Otherwise, if we will consider the higher Q value, the bolt spacing will increase. So that means the effect will not be much. So therefore, we will have to consider the bolt spacing obtained from Q original. So these are the bolt spacing in the lower row, which are obtained from the Barton's and Grimstead chart of 1993. So, and you know that improved Q value leads to reduction in the ultimate support pressure. See, P ultimate is 0.2 upon JR, joint roughness number, and Q to the power minus 1/3. So Q improvement means reduction in the support pressure. Now, in this table, you will see Q original, Q modified, and then the estimation of support pressure by the equation I have shown you in my previous slide. And you will see that up to 30% reduction in ultimate support pressure in poor rock mass is expected because of the improvement in the rock mass crowding surrounding the important thing is that we expect the improvement up to the bolt length, right, around the tunnel opening. So we have rock bolt and shortcut support. We already inserted the rock bolt, so there is no chance in changing the bolt spacing. Now, since the support pressure we expect because of the rock bolt grouting is reduced, so how can we manage that much pressure? Is by reducing the shotcrete thickness. So leads to reduction in the shotcrete requirement. Now, one example is shown here, and this is the Grimston and Barton support chart. Now you see the blue dot is corresponding to Q value 1, and I have considered the 10-meter diameter tunnel with ESR, excavation support ratio. In broader, if you consider about ESR, this reflects this factor of safety. The underground opening, which require more safety, is given lesser ESR value, and temporary mine opening and other openings of smaller size, the ESR value is more. So on y-axis here is equivalent dimension, that is the height or the width of the opening divided by ESR. Width we consider when we have to design the support of the roof, and height when we have to consider the design of the wall. Now, here the blue dot shows that the 10-meter size, and I have considered ESR 1. So you will see that 9 centimeter thick SFRS, fiber reinforced shortcut, is required. But when we consider the improvement in Q because of the grouting, you will see it will increase to 3, right? 1 will increase to 3. So it will move to red dot. The same size, same ESR value, the shortcut thickness will go down to 50 millimeter, 5 centimeter. And you know that before the rock bolt installation, just after the excavation, we have to have first layer of shotcrete, which is called the sealing shotcrete. And this should be at least 30 to 50 millimeter, right? So that means with the understanding that there will be improvement in the rock mass quality around the opening, you may not require the second layer of the shotcrete if you have proper thickness of the sealing shotcrete. So this is what I want to discuss. I have just concentrated on one point. And to conclude my talk, pre-grouting of the rock mass has been found to be effective in improving the rock mass quality. Now you can understand this, why I have mentioned this. Similarly, it is found that the grout of full column grouted untensioned, I'm emphasizing it on untensioned because when you are tensioning the bolt, the cracks will be closed. Untensioned rock bolts helps in improving the rock mass quality in case of poor to good rocks represented by Q between 1 and 40. The improvement in Q value is suggested to get modified rock mass quality. The improvement in Q is found to be more in poor rocks and less in good rocks. And you will see that if you have uncontrolled blasting, right? If you have uncontrolled blasting, then in even rock with Q is equal to 40, you may have large effect of full column rock bolt grouting. So I want to emphasize here that we should, always treat or handle the rock with care. Okay. The reduction in support pressure shall reduce the shotcrete requirement and therefore the supporting cost and time. Thank you very much for finding. Any question, please? Yes, yes.
I have only one single question. In case of mildly squeezing rock masses, will this help? Because generally the trend is to use as yielding support. So by applying pre-grouting, will we lose time for applying the yielding support?
What do you think?
Sir, I feel it should help, but in the case of poor rock masses, like with Q less than, like just more than 1, there should be some more deformation which can take place, and we won't be able to grout all the new cracks, the yielded zone which is formed.
Look, you see, you are correct. There should not be, there will be effect of this also, and the squeezing condition will reduce.
Yes, sir.
Now, why I am telling you is this, that we are expecting squeezing condition in poor rock mass. We say this, okay. What do you mean by poor rock mass? Now, out of our study, we have found out that we are expecting a squeezing condition with weaker rock mass having UCS less than 25 MPa, okay, and highly jointed, clay field joint, weathered joint. So now, since we are percolating the joint, we are cementing the joints through the grout of the untensioned bolts. So that means we are improving the rock mass quality or we are improving the strength along shear strength along the joints, right? We are increasing the shear strength along the joints. So the squeezing condition will reduce. That means the deformation will also reduce. And by the way, one more thing is that even in non-squeezing condition, we expect the deformations. But the difference is this, that in non-squeezing, the deformation is, as it is classified as, it is the tunnel is experiencing non-squeezing ground conditions when the deformation is less than 1% of the tunnel size, and when it is more than 1% and up to 3%, it is mild squeezing, 3 to 5% moderate squeezing, and more than 5% is the high squeezing. And you can study in the book that I have given one criteria that how to estimate or predict the ground condition which you are likely to get before the tunneling. So once your ground condition, your Q is improved, right? And you know that this much is the improvement, then accordingly you can use that Q value in your that ground condition prediction criteria, and then you can see that how your moderate is going to mild or mild is changing to non-squeezing ground condition. Okay, I think it's clear. Yes, please.
Grouting will help to improve the kiln quality.
No, through joints filled with clay, it is difficult to percolate. It will not. So these are the limitations. It cannot percolate that, because it will only percolate through the joints which are either open, okay, or which are partially filled. And if it is filled, then with pervious material, the clay is impervious, so it will not percolate through that.
Because shortcut will make enable to see the time, so we cannot stretch properly.
No. That is not the thing. You see, the step is that just after the blasting, scaling, mucking and scaling, first thing is the geologist will visit the face. Okay, he will map the geology. So your question is already solved. That means before sealing shotcrete, geologist visit, he will map all the joints and other things. Okay. Now it's clear to you. Because that will not be covered by that, by sealing shotcrete. First thing is that visit of geologist to the site, to the face, to map the geology, and then sealing shotcrete. This is the step. And if you don't have that much of standard time, then you should have either pre-injecting or the 4 poles or pipe proofing. Thank you very much.
If you have more questions. So if you have more questions, you can discuss with sir during the time.
Check 6 minutes or such.
6 minutes ago.
Well, greetings. Happy.
So before moving ahead to the next speaker, So before moving to the next keynote session, we would request Professor Stephen to present token of gratitude to Mr. R.K. Goel sir.
आपको देना है ना
Thank you, sir. So moving ahead, our next keynote session will be of Professor Derek Ellsworth, G. Albert Shoemaker Chair and Professor of Energy and Mineral Engineering and Geosciences at Penn State. He is a co-founder of the Center of Geomechanics, Geofluids, and Geohazards in the Department of Energy and Mineral Engineering at Penn State College of Earth and Mineral Sciences. His interests are in the areas of computational mechanics, rock mechanics, and in the mechanical and transport characteristics of fractured rocks with application to geothermal energy, the deep geological sequestration of radioactive wastes, and of CO2 unconventional hydrocarbons, including coal gas, tight gas shales and hydrates, and instability and eruption dynamics of volcanoes. So we would love to present the presentation sent by the sir.
He has sent the recorded talk, so we will play the talk. Start Chetan, start Chetan. चलो फुल कर लो फुल स्क्रीन प्ले करो.
Well, greetings. Happy to be with you on this wonderful day, hopefully in Patna. I'm sad that I'm only with you virtually. The weather, as you know, at Penn State in the wintertime in the northern, well, you're also in the northern hemisphere, as you know, is quite cool at our latitude. And so I think the weather will be much more pleasant where you are right now, and I'm envious of you. But anyway, thank you for the kind invitation to be able to join you. The topic of the discussion today is the challenge of creating, sustaining, and characterizing permeability in unconventional reservoirs. And with respect to unconventional reservoirs, I mean that quite broadly. So it includes unconventional hydrocarbon reservoirs that we think of, but it also includes other unconventional reservoirs, such as deep geothermal reservoirs, where again, with no native permeability, you have to create the native permeability to be able to withdraw the energy holding heat transfer fluids and bring them up to the surface and also inject them into the subsurface as well. So it's with that background with regard to the energy transition, the necessary components for the energy transition, that we'll discuss these things today. In particular, we'll talk about some of the work that we've been doing in unconventional fluids to drive fractures, gas fracturing, either static gas fracturing to increase the complexity of the resulting fractures, dynamic gas fracturing also to increase the complexity of the fractures, and by using methods of modeling to be able to understand whether you can actually drive proppant into those fractures that you've created driven by gases such as CO2 in liquid form. Also, secondly, realizing that when you generate fractures to create porosity and then permeability, that typically that is done dynamically and as a result of small earthquakes, micro earthquakes in shear or in tensile opening, then the question arises whether you can use the information that you get from those micro earthquakes to say something about the connected fracture networks you create, and whether you can say something remotely about the magnitudes of the permeability you expect to get from those. So it's well known that in unconventional reservoirs, the ability to make permeability can sometimes be short-lived. Not so much the ability to make permeability, but the ability to be able to drain fluids from the wall rocks by the very slow diffusive processes into the main hydraulic fractures, either created as a massive single hydraulic fracture or as multiple reactivations of natural fractures. And decline curves are typically steep in the first year or 2 years, maybe resulting in down to about 20% of production after a couple of years. And all attempts to change this by trying to reset it, for instance, by increasing fluid pressures to try and re-stimulate, such as shown on the left, occur in incremental gains, but typically are reset by creep compaction within the system and the loss of permeability that continues. So one key question that arises during hydraulic fracturing is, what is the best form of a hydraulic fracture? Is it going to be the longest or tallest or the widest along its length? Is it going to be the one that's accepted the largest proppant charge and therefore is most permeable along that length? Or is it the one that's most complex and reactivates the most natural fractures and is therefore able to reach a larger volume within the reservoir? And so what we'll talk about is we'll talk about static gas fracturing, the ability to create complex fractures, the ability to transport proppant along those fractures and then examine their permeability, and also then talk about the potential that in the case where we can drill more inexpensively than we can fracture, then perhaps we can use narrow diameter wells with explosive gas fracturing to be able to create volumetric permeability, which is able to obviate some of these problems with the rapid decline rates that we see within fractures. We certainly know that in static gas fracturing, that in some respects, the complexity of the fractures is influenced in a big way by the fluid which is used. One big distinction seems to be between the use of subcritical and supercritical fluids. Supercritical fluids, such as supercritical CO2, nitrogen also, are capable of giving quite complex fractures at relatively low breakdown pressures, and so might be favored over other liquids and other subcritical gases which might be used in such a system. But one key issue in driving these fractures using a variety of different fluids is not only the efficiency of the fracturing that can result in terms of the length of extension, but also how capable you are of propagating proppant along the length of the fracture to act as a bridging agent and to retain the permeability that you've created. And so if you look at comparing slick water, LPG, CO2, and reusing ethane, which you recover from the reservoir, or fracturing with nitrogen, you can see that in each of these cases, certainly the fracture lengths diminish, even though the complexity might be elevated, and certainly the ability to be able to carry proppant along the fracture is also diminished in the case of the lighter gases. If you use CO2 and you change the rate of production, of course, you can increase the length of the fracture to beyond that of slick water in the bottom example here. But the proppant still rests relatively close in to the wellbore and is not carried to the furthermost extremities of the fracture. So one solution to the low propagation distance of proppants in these gas-driven fractures is to, instead of using gas alone, is to use foam gases of different qualities. And you see if you used foam nitrogen in this particular case, the propagation along the fracture is much further. Its distribution is somewhat different than the case of slick water in that it's the dune height is relatively shallow, but there is some changes in permeabilities with proppant being kept high up within the fracture. And with the known distribution of proppant along the fracture, you can look at the behavior of a single hydraulic fracture within a set of stages along a horizontal well, and you can look at the cumulative gas production that occurs along the lifetime of that system. And indeed, you find that foams and gelled proppants of gases are able to sustain permeability to give high productions of the order of slick water, although at greater expense. One other opportunity in using a single well and massive hydraulic fracturing, of course, is to use more drilling and less hydraulic fracturing, in which case, if the cost of drilling is reduced and you can drill small diameter wells, then you can use a peppering of a large number of these wells to be able to access the reservoir and maybe have fractures that perhaps go only a few or tens of meters away from those wells, but have much more volumetric coverage in creating fracture surface area within those regions. So to fully utilize this technique, you could use gas fracturing, not static gas fracturing in this case, but dynamic gas fracturing, in which case, rather than developing a bi-wing fracture where it's controlled by the stress regime, the dynamic effects of the impulse applied to the inner borehole has the effect of overcoming the static stress field and resulting in radial fracturing. This kind of behavior is well demonstrated in the Cardox fracturing technique developed by Yushin Kai at HPU, used primarily in coal, where overpressured CO2 is released with a very sharp rise time and is able to jet into coal and create a radial fracture pattern with quite short diffusion distances to the individual fractures. The advantage of this, of course, is that the fractures that result from this tend to be radial. They're not controlled by the stress state. They tend to be quite penetrative. Perhaps they don't go as far as a massive hydraulic fracture away from the wellbore, but they're able to generate very high permeability in the close-in region of the wellbore. They tend to be a small number of large fractures, maybe 3 to 6. And so one question is that in this explosive or high-pressure gas fracturing with fast rise times, what are the mechanisms controlling this behavior? It's clear that since the number of fractures is always, approximately 6, that there are two main processes that are acting. One is the dynamic stress wave, which creates a large number of radial fractures in the periphery of the wellbore, and then the quasi-static gas overpressures, which then utilize either all of those fractures or a subset of those fractures to drive them much further away from the wellbore. So the first interest in this behavior is in the dynamic body wave which results. And so we can look at a rise time of the pressure that's applied on the inside of the borehole. It results in a dynamic wave in terms of displacement that emanates from the wellbore outwards, and also a pressure wave that follows that. And if we follow the locus of the pressure wave that results at a variety of times, that locus gives us the radius to which fracturing would occur in tension as that body wave stresses the exterior of the borehole. And typically that can be of the order of a few to 5 radii of the borehole. So not very far, but at least they're starter cracks. And of course, there could be an infinite number of those starter cracks that emanate radially from the borehole. And you can actually show that depending on the magnitude of the rise time, for very relatively long rise times, in this case 2000 microseconds or 2 milliseconds, then the radial dependence of the peak tensile stress is the same as the static solution and varies as 1 over r squared. So that defines the first episode of the behavior, that we can get these radial fractures extending to maybe 3 or 5 radii beyond the periphery of the wellbore and in all directions, but we want them to go much further than that. And of course, driving that is the influence of the gas overpressures, which will propagate these individual radial fractures, perhaps not all of them, but propagate some of them. And the question is, in what form will this infinite number of radial fractures be propagated away from the borehole? And the easiest way to look at that is by using linear elastic fracture mechanics and using these 3 loading systems that we're looking at here. The first is the loading of the wellbore itself. The second is the loading of a small fracture and a slightly longer fracture in this kind of arrangement here to a given length along those individual fractures. And then the loading of both the short fracture and the long fracture to see which one will preferentially propagate. And by looking at that behavior, we can see whether there's a down select in terms of the number of fractures that we start off with to see which ones will continue to a much greater radius away from the borehole. So the easiest way for us to determine whether the individual fractures, if we have a long fracture and a short fracture coming out of the borehole, we can look at the stress intensity factors of the short fracture and the long fracture in this particular case, And if the stress intensity factor of the short fracture is greater than that for the long fracture, then preferentially this one will lengthen as the other one stays static. If we look at it for a variety of geometries for 4, for 6, and for 8 fractures, then for at least 2 fractures, we see that the short fracture will propagate. For these, they'll both propagate similarly. But for the case where we have 6, it will tend to be that the long fractures preferentially propagate, which have a higher stress intensity factor, at the expense of the shorter fractures. Next, we can, of course, look at the impact of gas loading, where gas permeates the fracture. And again, the same behaviors. For 2 fractures, the stress intensity factor for the short fracture is larger, so this propagates. For 4 fractures, the stress intensity factor for the short fracture is larger, so this propagates. For 6 fractures, the stress intensity factor for the small fracture is roughly the same, so you'd expect to have 6. And for 8, we get the case where actually the longer fractures predominate over the short ones, and therefore the large fractures will propagate in these individual cases. They'll accentuate the non-uniformity, and so we'll be stuck with a maximum number of fractures emanating from the borehole, which might be, as we see in reality, of the order of 6 per borehole. And of course, that's what we've seen in the past, is that we have a small number of fractures seen to emanate from the borehole. Typically, it's the order of 3 to 6 in magnitude, rarely larger than 6, but these can potentially go a considerable distance. And in going a considerable distance, they're able to tap the resource further from the borehole. So it's clear that from generating permeability through creation of fractures, either as a single hydraulic fracture or as these multiple radial fractures, we can increase permeability. Presumably, we can also measure that increase in permeability by standard well tests. But the question arises is as to whether we can make predictions of what permeability evolution might be as a function of the events that contribute to that permeability evolution. So what we could do is we could use the magnitudes of individual events, such as we have done at the Newbury Geothermal Project, to try and make predictions of the evolution of permeability just by knowing magnitude, location, and making some assumptions about fracture geometry. And if we're able to do that, we end up with a plot of predicted changes in permeability, here shown in colors, as a function of time and a function of radius of the seismic events away from the well, which can be correlated against the envelope of the migration of the pressure front, according to the diffusion equation, which is marked out by the acoustic emissions, which constrains in some way the permeability that you predict based on connection with the seismicity into the behavior in the reservoir. But in this case, the data are quite poor because they're gathered at 3 kilometers depth, 3 kilometers away from the accelerators which measure their behavior. And so we need some better way to constrain any kind of models which would link permeability with the seismic events that cause them. So one approach to finding better data is to use this DOE EGS collaboration experiment at the Sanford Underground Lab, the Deep Underground Science Lab in the central part of the US. The stimulation experiment was run at a depth of 1,500 meters, and it was prosecuted from an adit with an injection borehole, a recovery borehole, and a whole series of instrumentation boreholes, where the injection borehole was equipped with one of these SimFit probes that not only is able to inject fluid into the formation at a controlled rate and a measured pressure between 2 packers, but also is able to measure the displacement that occurs on any fractures with this clamp mechanism that is able to measure the relative displacement both in shear and normal displacement during the experiment. So this well-instrumented experiment at 1,500 meters depth at relatively recreated in situ stresses, but where you're only a factor of maybe 10 meters away from the experiment, with the seismicity that you get from it being very well defined, and running this experiment in a variety of different modes. running it in a modes attempting to do hydraulic fracturing, attempting to do hydraulic shear, and to both measure the injection rates and pressure magnitudes, which give you some estimate of permeability, and also measure the ongoing seismicity as the stimulation proceeds. So these are perspective views of the adit, the injection borehole, the recovery borehole, and the observation boreholes, which had seismometers and accelerometers set in them. And the injection experiment was run in these 5 different epochs of injection stages, if you like, where the magnitudes of the pressures were stepped up during the experiment. The magnitudes of the injection rate that resulted from those pressures was also measured to correspond to those. And the seismicity during these 5 different epochs was also measured together with the location relative to the wellbore. So magnitude shown here, but also the distance of the seismicity relative to the wellbore. And so one thing that can be done within this is that we can attempt to use these very high quality data to be able to say something about this linkage between microearthquakes, their magnitude and location, and the size and features of the permeability field that they develop. So the approach to evaluate these high quality data is in 3 steps. The first step is purely based on the data itself, is that if we know the injection rates and the overpressures, then deterministically, if we assume a geometry of injection, we can define a deterministic magnitude of permeability from that injectivity. So that's a given. The second opportunity is that if we know the injectivity and the permeability that results from that over time, and we also have measurements of the seismicity, we can try and use machine learning to take some of the early episodes of the injection, maybe episodes 1 through 3, train the data for injectivity, permeability, and microearthquakes on that data, and see if in episodes 4 and 5 we can make a prediction of permeability directly from the machine learning algorithm and from the microearthquakes alone. And thirdly, whether we can define any deterministic ways of being able to define the evolution of the permeability field, again, directly from the magnitudes of the earthquakes alone. So we have 3 potential ways to do it. Deterministically, using machine learning, and using a deterministic evaluation of the mechanisms, where we link the mechanisms causing the earthquakes to a mechanism to concurrently develop permeability as a function of that shear slip. So the first step is to be able to evaluate the time history of permeability merely from the injection data. So we have a cumulative incremental number of events, microearthquake events. The cumulative number evolves over the individual episodes, episodes 4 and episodes 5. And so what we have to do is be able to define an injection geometry where the injection along a single well is to an outer pressure boundary, which evolves as the injection experiment proceeds. And we can get the outer conduit of this by merely taking the cumulative number of seismic events that we have, say taking 80% of them, and assuming that this 80% represents the outer boundary of our moving domain, which includes flow. We can use a radial steady solution for flow within that domain. And if we know the magnitude of how that contour, the radius of this evolving pressurized zone evolves over time, we can try and fit that to the data to be able to use that to calculate the magnitude of permeability, since we need a characteristic length over which pressure drop occurs with a given flow rate to define the permeability of the system. So that gives us an ability to evaluate in a deterministic way the evolution of permeability within the system. So with those magnitudes of permeability, we can do 2 things. We can either use machine learning to be able to check whether we can actually predict those magnitudes by training on earlier injection periods and testing on the future behavior, or we can attempt to do it deterministically. If we try and use machine learning, which we do here, we use these first 3 episodes. We train on the data. The data that we use are the maximum, minimum, and mean magnitudes of the earthquakes together with their variance within individual time windows of, say, 5 minutes. We look at the distance of the individual events away from the wellbore, both the maximum, minimum, and mean values and the variance within those time windows. We look at the number of earthquakes, and we look at the mean value of the injectivity during that time. We used a random forest method, XBoost, to be able to evaluate those behaviors, define which features are most important in this, and then we attempt to predict the behaviors in the final 2 episodes, episodes 4 and 5, where we look at the prediction, which is shown in red here, with the measured values of injectivity, which are shown in black, which follow quite closely from those individual magnitudes. And so we're able to use the training of this to be able to make that prediction. So if machine learning is able to predict those behaviors in the future, then presumably there's some physics-based mechanism which is causing that behavior. And so the most likely culprit for that is, as we see both in the laboratory and both in the field, that as you pressurize faults and allow them to slip, then as slip occurs, you get dilation of the faults that is ultimately outpaced by slip. And this dilation is what results in a change in the aperture of the fracture, and therefore an increase in the permeability in the system. So one thing that we can potentially do is realize that this behavior, where we get dilation that occurs within the remobilization of the fracture, of course, the remobilization of the fracture occurs with some output of seismic energy. And so one potential physical linkage that we could generate would be between the dilation that occurs, which results in a change of permeability, and the magnitude of the seismic energy that results, in this case measured within a laboratory system of the same rock that's present within the Icgeid collab, be able to link the magnitude of permeability with the magnitudes of the events that are causing it, and then feed this directly into this third method to be able to make predictions of permeability as a result of these scale events. And so the linkage is that if roughness is a fractal property, then it's scale independent. And so we can scale this to larger scales. So larger magnitude should result in larger changes of permeability. And using that relationship, but at larger magnitudes, should allow us to be able to define individual permeability creation events from individual microearthquakes. So that's exactly what we do. We take the individual microearthquakes, we link the magnitudes of those events with the relationship that defines permeability as a function of magnitude. We therefore can define the permeabilities of individual fractures that are reactivated in the beginning, middle, and end of episode 4, and the beginning, middle, and end of episode 5. And if we have this permeability field defined, we can use that to define the overall permeability within the system. And within this perspective view, you can just see that as a result of the stimulation as it continues in time, we generate these features which are viewed in situ within the wellbore records that are apparently resulting from the activation or the reactivation of fractures within the system. And then finally, we can take for the system our deterministic magnitudes of permeability, which are measured in episodes 4 and episode 5, increasing from episode 4 to 5 because it's a stimulation and its permeability is growing, and check that with the averaged values of permeabilities recovered from the individual reactivation of fractures, averaged on some scale, on a mesh that's 0.3 meters in size through to a mesh that's 0.7 meters in size. And the averaging process gives a distribution of overall permeabilities of the system, which changes. And of course, these match in a reasonably coherent manner the magnitudes of the individual measured values just at these individual length scales of the averaging process. So these attributes are summarized here, that we can use static fracturing to generate porosity in reservoirs and therefore create permeability. That using static fracturing, we can get complex fractures, but perhaps have difficulty in driving proppant into those fractures to keep them open. In the case where drilling is perhaps less expensive than hydraulic fracturing itself, then perhaps we can afford to have relatively small diameter boreholes that are close together and massively fracture them with dynamic gas fracturing to be able to create quite volumetrically permeable zones to be able to recover fluids that perhaps overcomes this innate limitation of large-scale hydraulic fracturing, where the diffusion lengths to the fracture become large at later times, and try and keep those to a minimum. And finally, that potentially by recognizing that in fracturing rocks, we create seismicity, and that in a mechanical way, a mechanistic way, the slip and dilation of fractures is linked to the permeability, and slip and dilation of fractures is also linked to the magnitudes of the seismic events that results. Then there's a potential to be able to link seismicity and permeability, and to use that to be able to characterize reservoirs at relatively high resolution to define exactly what the permeability structure is within the subsurface. So that's what I'll chat about today. Thank you very much.
So thank you, Professor Derek. He couldn't come because he couldn't get the visa on time. So, but we are still thankful to him. Thank you for him.
So I would request everyone to, so now we have a lunch break. So I would request everyone to take the lunch outside. Also, after lunch, we have the poster, we have the industrial presentations. So please be back on time.
Gentlemen, I'll just take 5 minutes. I have to leave, so I'll just request for 5 minutes. And I promise you I'll not bore you. All right. So let me start introducing myself. I'm Colonel Shaumendra Banerjee. A couple of students have already met me. So today I'm representing Terre Armée. From Indian Army, serving for 26 years, I've gone into Terre Armée. सीधे आर्मी से थोड़ी टेढ़ी मेढ़ी आर्मी, ठीक है? So first I'll introduce, just in 2 slides, what is my company all about. This company is the father of, or the inventor of, reinforced earth. Now, this year we are celebrating 60 years of reinforced earth. Now we are all geotech engineers here, and the importance of the reinforced earth cannot be underemphasized here. With this introduction, I'll come to, since 1995, we are here in India, and the name to claim to our is a 102-meter tall structure, a reinforced structure which is built on just a 4-meter width, 102-meter tall. Here I can, yeah. All right. Henry Vidal, everybody must have heard of, 60 years. In India, since 1995, the first reinforced structure was constructed by Terre Armée in Jammu. Number of squares of reinforced earth, retaining walls, hydraulic structures, numerous of them. We have already done it. Done it all, seen it all. And the best part of this is God has been also kind, no failures. So we are into protect, cross, and step. I'll not go into this. I'll bring it to the most important problem of a hilly terrain, is the steep slope. 120 meters, 100 meters, 70 meters. What do? Do we construct a complete structure right from the base, or we look for a space in between and work on it? What do? We have solutions. We take the help of the, now this is a typical example. This is again when I was road administrator in Uttarkashi. I had this road Rishikesh to Uttarkashi with me. A conventional retaining wall. What happens? Splits into two. Differential settlement. Again, this is Tindharia. The complete landmass had come down. What do? Don't have a solution. The height of the slope is almost 150 meters. We build a wall. How do we build a wall that tall with such a small width? Simple combination of techniques. Use the existing face, reinforce that face with nails. From that face, we take out straps. From that straps, we built up a false fascia. Use the existing place to build up a bigger space. Sounds easy, difficult, because you have got drainage problem. This is steep. You won't get a complete, this fascia is almost vertical. So workmanship, not the only technology. I was convener yesterday to one of the sessions. One thing is it comes down to transmission into land. It is the workmanship. Get it? It has to be there. So with that, we got our existing width has been increased and we have got a vehicle. This finally looks like this. You might look like this is a fascia, is a concrete fascia, but no. The wire mesh, behind the wire mesh it is hand-picked boulders. Technology combined with good workmanship is the ultimate solution and it works well. Now in photographs, I'll tell you what existing space, wire mesh, nails, traps, false fascia, filling. Done. And we have a structure. Again, I'll skip this video. We were talking about walls, difference between wall and slope 70 degree, but the entire forces changes. So with these slopes also, as tall as 40 meters, these are existing structures and working very well, functioning very well. Another biggest problem that is faced in the hilly terrain is the toe erosion, undermining, abutment losses because of the fast flowing, the kind of discharges it has, rainfall intensity, cloud burst, and the disaster is endless. This is one of my projects when I was road administrator again and a bridge in charge in Joshimath. This is a road from Joshimath to Malari, and a cloud burst took place and the entire abutment got washed away. But with help of little scout protection, this bridge has now been recommissioned and working. How? With help of a little bit of hydraulic system and technology, which is already in, this is from extract from ISCSP 48. A fabric foam mattress filled with concrete. Most of us must have heard of it. But what is the difference? This fabric foam mattress has got a cable. Understand? If anything has been tied up with a cable, the strength of that is increased by nothing less than 60 to 70 times. How does it happen? These are the hidden slides. So sorry for that. I'll directly skip it and go to. So a lot of modeling is done, but I'll come to what finally its shapes looks like. Mattress. Another advantage of that is articulating blocks. At the end of each mattress, these are heavy blocks weighing of around 1000 to 1500 kgs. Concrete. The moment the scouring takes place, it articulates. It places itself, it launches itself in that particular undermining. So, scouring, but there is an articulating block that covers it immediately. So the next action of scouring does not take place. So that is again an advantage of this particular technology. Benefits underwater, very quick in construction, almost in 15 days, 1.2 kilometers, unheard of. And if we have something where a disaster has just happened, And we need to have that road intact, and we need to work on it. Now the solutions. Very simple: profiling, laying of the mattress, and then filling it up with concrete. The entire process, if done properly, this particular timelines can be very well met, and we have met it. We have already done it. Video, please skip it. Testimonial. You know, picture speaks 1,000 words. 18-year-old project, Bhutan. Look at the kind of velocity this canal has surviving. Another testimonial, which I don't have everybody has heard of the recent disaster in Sikkim. This tech revetment near a bridge called Dikchu Bridge, it saved the entire formation. NHPC has acknowledged it. So we have technology. Use it at the right time. You will reap the benefit of it. A stitch in time saved 9. Okay. Embankment. Again, part of it, we have done it all. And rockfall, there are many solutions, but I will not go to it. Again, this is one of my road sector in Rishikesh, Dharasu, but I will skip it. A lot of tests has been done. I'll come to the last slide. Okay, this is, I just wanted to tell you, this is one excellent work that has been done. This is a structure which is being able to this is a structure almost 12.4 ton. This is the bund which is there. This bund, has been tested with this kind of force. And this is not embedded. This is not dug in. This is just standing on its own self weight. With this kind of the structure which is bound, the kind of energy that it absorbs, it is able to take that hit. Something which we can use it for saving any important installation which is around us. Structures, skip it, I'll skip it. These are all my practical things. This is Jojila, Jojila that we have done, not in Terre Arme. I've just retired 1 year back while being in service in PRO. So these are international photographs. This is again Z mode. APCO, the project is going on. If this, imagine this would have gone down, what would have happened to that habitation? So again, design and information both work together. I'll finally come to my final slide because after that I'm standing between the lunch. So, yeah. Again, we talk about a lot of us must have not even gone to that high altitude of 18,000, 19,000 feet. The kind of avalanche that it places and the kind of debris that it fills in, it is actually a design in itself. Yesterday, Geoburg was here. Fantastic work is done by the entire fraternity. I'm not talking about myself only. The entire fraternity combined together, the kind of technology that we have is immense. All right, I'll end this with this slide, wherein right from the coastal protection to the mats, to soil stabilization, right up to the hills. If we are students here, not only Terre Arme, it's Geogroup, McAfee, or Innovative Solution, all of us, the entire plethora of solutions are available. The right solution used at the right time, at the right place, will yield you the desired result. Thank you so much for the time. Thank you so much. And I'm really grateful for the time. Thank you.
Thank you so much, sir. So I would request everyone to note the time. The lunch break is for 1.5 hours and be back for the industrial presentations later on. Be back by 2:30. Here only.
इसको क्रिएट